Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically from now today onwards we are going to start a new topic in this statistics series, and that is basically hypothesis testing. Okay, single mean and single proportion. This is the name of the topic, that is basically the hypothesis testing that we are going to start from today. Okay, so let me just quickly take one color and let me just put on the heading. After that I would let you know that what we are going to discuss under this topic today. Right, so here it goes that the name for my topic is hypothesis. Okay, just one second. Yes, that is hypothesis testing. Okay, so this is the topic that we are going to discuss today, that is hypothesis testing. Now basically, first of all, I would let you know that what actually it is, right? I would just tell you that what actually hypothesis testing means. After that I would tell you that basically to perform a hypothesis testing, basically a statistician actually follows what process for doing that thing, right? This is the topic that we are going to discuss today. The first thing that is that what actually we just meant from hypothesis testing, what are the things that we need to consist in them, and after that basically what is the proper method for to perform this hypothesis testing. Okay, this is the whole topic that we are going to discuss today. So let me just quickly take one color and let me just let you know first of all that what actually hypothesis testing means. Okay, I will just tell you that what actually we just meant from hypothesis testing. Right here. Okay, just one second. Right here I will just start. So I would just write down the definition here itself and you can just note that down on your notebook. So whatever you're just using. Okay. So a hypothesis test involves, what is this is basically involves what we just do in this. So a hypothesis test involves collecting data. It basically involves the collecting of data. Okay, it involves collecting data from a basically it involves collecting data from a sample and basically evaluating the data and evaluating the data. Okay, this is basically what we just meant from hypothesis testing. So a hypothesis test actually involves collecting of data from a sample and basically evaluating that data, right? This is actually what hypothesis test means, and this is actually what we just do in hypothesis testing as well, right? Now basically after that I have some more things to let you know about this thing. So I would just write, then the statistician means you who are just performing the statistics operations and all those things, right? So then the statistician makes a decision. Okay, after performing sampling the data and evaluating the data, the statistician makes a basically decision. Now what kind of decision is that? So it makes a decision as to whether or not there is sufficient data, there is sufficient evidence based upon analysis of the data. So as soon as the data is evaluated and we sample the data and evaluated data, then after that the statistician makes a decision. So basically as to whether or not there is sufficient evidence based upon analysis of the data. So basically the statistician checks that whatever the evidence, whatever the things, whatever the data and evaluation has been done, so that is basically based upon the analysis of the data or not. Right, this is the thing that the statistician performs. So analysis of the data and basically to reject the null hypothesis. Now basically what is this null hypothesis, that I'll be letting you know maybe in the next video. So but for now we just understand this is the way that how this hypothesis testing works. So basically this test involves collecting of data from a sample and evaluating the data. Okay, this is the first thing that it actually involves. After that, the statistician makes decision as to whether or not there is sufficient evidence based upon the analysis of the data to reject the null hypothesis. Okay, this is actually what is done in this hypothesis testing, right? Now, basically, okay, just one second. Now basically the hypothesis testing consists of two contradictory hypotheses. Okay, basically there are two things. Let me just take this color, write that down. So I would just, okay, right here. So I would just add on the thing that basically I would just add the hypothesis. Okay, so it is basically hypothesis testing consists of, so hypothesis testing consists of two contradictory hypotheses, consist of two contradictory hypothesis. Okay, contradictory hypothesis, and basically, or you can just call it as statements all as well. Okay, just simply call it as statements. Just call into simple English language. So I would just write that thing. So hypothesis testing actually consists of two contradictory hypotheses or statements, and what are they? So the first one is that a decision based on the data. Okay, a decision based on the data. This is the very first thing, that a decision based on the data. And basically after that, what do I have? A decision based on the data, and the second thing, let me put a comma here, and the second thing is a conclusion. Okay, and a conclusion. Okay, so these are the two, you can just say contradictory hypothesis or statements which we have here. So the first one is that basically which you need to find out in the hypothesis testing, that is a decision based on the data, and second one is basically a conclusion. Okay, these are the two things which you need to perform. Fine. After that, basically what I was just saying is that I would be letting you know a procedure, a way that basically how to perform that hypothesis testing, right? A correct way that is statistician follow for finding out the hypothesis test. Right, so let me seek one new color here, and let me just start on with the things here. Right, and start here, I would be writing to perform a hypothesis test. To perform a hypothesis test, I will put a comma, a statistician will. And after this, basically I have some points to do here, which actually the statistician will actually follow, right? So my first point goes like this, that set up two contradictory hypotheses. Set up two contradictory hypothesis. I would just write that hypothesis here as well. Hypothesis. This is the very first step which you should follow for finding out the hypothesis test, that is setting up two contradictory hypotheses. Moving towards the second. Now, second one is to basically collect the sample data. Collect sample data. This is the second step which you should do, that is basically collection of the sample data. Now, moving towards the third step. So basically third step says that determine the correct distribution. Determine the correct, okay, just let me come down so that it's visible in the whole sentence. One second. Yeah, here. So determine the correct, I would just add on here distribution. So determine the correct distribution, TIO, and determine the correct distribution to perform the hypothesis, test. Right? This is the third step which you should follow to determine the correct distribution. To perform the hypothesis test. So then, first of all, you just need to basically make the two contradictory statements. Hypothesis. After that, you need to collect out the sample data. Then third, you need to determine the correct distribution to perform the hypothesis test. Okay. Moving towards the fourth step which you need to follow. The fourth step says that analyze sample data. Okay. Analyze the sample data by performing the calculation. Let's say sample data by performing the calculations. That ultimately will allow you to reject or fail to reject the null hypothesis, null, and here we go with the hypothesis, THESIS, right? So to analyze the sample data by performing the calculations that ultimately will allow you to reject or fail to reject the null hypothesis. So this is the very fourth step that you should follow while doing out the hypothesis testing. Right now, moving towards the fifth and the very last step is that, let me come down here and let me write down that step here, this thing. So, and the last step is to make a decision and make a decision and write a meaningful conclusion and write a meaningful conclusion, right? So this is the very last step that you should follow in this hypothesis testing. So make a decision and write the meaningful conclusion. Let me just go above and repeat out all the steps which I have just written here, so that it would be more clear to you. So to perform a hypothesis test, a statistician will set up two contradictory hypotheses. Very first step. Second, we'll collect out the sample data. The third step goes to determine the correct distribution to perform the hypothesis test. The fourth one goes analyze sample data by performing the calculations that ultimately will allow you to reject or fail to reject the null hypothesis. And the fifth one goes that make a decision and write a meaningful conclusion. Right, so these were the steps that you should follow to perform a hypothesis test. Now, let me just quickly give you an overview regarding whatever we had just discussed today. So, basically, first of all, we had seen that what is hypothesis testing, right? So, a hypothesis test involves collecting data from a sample and evaluating the data. This is actually what a hypothesis test involves. Then, basically, the statistician makes a decision as to whether or not there is sufficient evidence based upon analysis of the data to reject the null hypothesis. Right. After that, hypothesis testing consists of two contradictory hypotheses or statements, a decision based on the data, and a conclusion. So this is the main important point which basically comes at in hypothesis testing. It consists of two contradictory hypotheses, or you can just say it basically consists of two statements. So the first statement is a decision based and on the data, and second one is a conclusion, right? So basically, I hope that you got the idea regarding the hypothesis testing, that what it is, and basically what are the procedure, what are the steps that you should follow for following out this hypothesis testing. So basically, in the next videos, we'll be seeing more things about the hypothesis testing, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now basically today we are going to discuss about two topics, and that is basically null hypothesis and alternate hypothesis, right? These are the two topics that we are going to see today, and related to this we are going to see some examples also. So let me just begin out with the topic name, and that is basically the first one is null hypothesis, null hypo, and that is thesis. Okay, just give me 1 minute. Let me just make a pen a little bit like thinner. This is okay, I guess. Right, let me just write that here, that is null hypothesis. Okay, the first topic. And after that we have even alternate hypothesis. So I will just write that hypothesis here as well, hypothesis, right? So these are the topic that we are going to discuss today, the null hypothesis and the alternate hypothesis. Now, in these topics, basically, first of all, I would let you know what we just understand from the null hypothesis and the alternate hypothesis, right? That's what we just say from these. So, let me just start writing up the things here. So, the actual test, okay? The actual test begins by considering the actual test begins by considering two hypotheses. Okay, the actual test basically which we have, it begins by considering the two hypotheses. So the first one basically I will just name this as they are called the null hypothesis, null hypothesis, and alternate hypothesis, right? So basically here it is written that the actual test begins by considering two hypotheses. They are called the null hypothesis and the alternate hypothesis, right? So these are the basically two hypotheses on which basically the actual test begins. Now even in the previous video at some places I had discussed about taking the name for the null hypothesis as well. So just read out this line, that the statistician makes a decision as to whether or not there is sufficient evidence based upon analysis of the data to reject the null hypothesis. We have seen this word in the previous videos, right? So this is the same thing that we are gonna discuss right now today, and here it is number 36, right? So let me just begin now with the things for now. But before this, I just want to let you know one thing regarding the null hypothesis and the alternate hypothesis. So basically, let me just give you one hint as well. So basically, these hypotheses, so I would just write, these hypotheses contain opposing point of views, opposing, O-P-P-O-S-I-N-G, opposing viewpoints. So this is the one thing which we have here in this null hypothesis and the alternate hypothesis, that these contain the opposing viewpoints. Okay, let's begin now with both of these right now. Let me just quickly take another color right here. So let me just come down and start with the things here. Fine. So it goes. So basically, first thing we basically define and like make the null hypothesis which H naught. Okay, we just denote the null hypothesis with this H naught. Okay, so H naught is basically the null. Okay, that is null. Just 1 second. That is the null hypothesis. Okay, null hypothesis. Fine. So H naught is the null hypothesis. Now, basically, what we just meant from null hypothesis. So moving towards that thing, let me just write out that here. So it is a statement. So I would just add on in this line only. So it is a statement. So it is a statement about the population. Simply write pop. Okay, instead of full population, simply write the short form. So it is a statement about the population that will be assumed to be true unless it can be shown to be, let me just come down, unless it can be shown to be incorrect beyond a reasonable N-A-B-L-E, beyond a reasonable, and here we come. Okay, 1 second, let me come down from here, reasonable, and let me just 1 second, let me just remove this out from here, and let me take the same color once again, reasonable, and here it is doubt, right? So basically H naught, that is the null hypothesis. So it is a statement about the population that will be assumed to be true unless it can be shown to be incorrect beyond a reasonable doubt. Okay, so this the null hypothesis is assumed to be true till the point it can be shown to be incorrect beyond a reasonable doubt, right? This is the whole idea regarding the null hypothesis. Fine. Same I've been telling you about the alternate hypothesis as well. Okay, so here comes the second thing, and that is basically my HA. We basically denote it with the H. Null was H naught, right? And this is basically denoted as HA. And I would just write here the alternate the alternate hypothesis, right? So let's get started and see that basically what comes here. So it is a, now this is the alternate hypothesis. So it is a claim, it is actually a claim about, it is a claim about the population, it is a claim about the population that is contradictory, that is contradictory to H naught, and what we conclude, and what we conclude when we okay, that is when we reject H naught. H naught is basically my null hypothesis. So the alternate hypothesis says that it is a claim about the population that is contradictory to H naught, and what we conclude when we reject H naught. Okay, so basically it is a claim about the population that is contradictory to H naught. Okay, and what we conclude, we reject H naught. Right, fine. These are the two hypothesis, that was null hypothesis and as well as the alternate hypothesis. Now let's take some example for solving out both of these. Let's say I want to take an example, so I would just write an example like this here. Right, let's say my first example is that we want, okay, let's say we want to test whether the mean grade average, is whether we just want to we want to test whether mean grade average in American college, let's say in any American college, okay, in any American college is different, okay, DIFF like this only, is different from 2.0, and basically in bracket it is, let's say, out of 4.0, right? Let's say this is the question that we want to, okay, just one second, that we want to test whether the mean grade average in American college is different from 2.0 out of 4.0. Okay, so basically if I just want to find out the H naught and HE for this question which I am getting, so what will be my H naught here? So H naught will be my mu. Okay, that is my mean, and that is actually 2.0. So H naught is actually the null hypothesis, right? And if I just want to find HA, and that is HA is basically not my mu. Okay, so that is mu not equal to 2.0, that is average not equal to 2.0, and this is basically average equal to 0, right? This is actually how we write out the null hypothesis and the alternate hypothesis. Just read out the definition once again for the both. So the null hypothesis says that it is a statement about the population that will be assumed to be true unless it can be shown to be incorrect beyond a reasonable doubt. Okay, and the alternate hypothesis says that it is a claim about the population that is contradictory to H naught. H naught is basically my null hypothesis, and what we conclude when we reject H naught. So let's say we had just taken an example for this, that we want to test whether the mean grade average in American college is different from 2.0 out of 4.0, right? So in that case, basically I was getting that H naught, that is my mu, that is my average, mean you can just say. So mu, that is my average, which is my H naught, that is basically my null hypothesis is 2.0, and my alternate hypothesis is basically average not equal to 2.0, right? So this is about how the null hypothesis and the alternate hypothesis actually works, right? I hope that you have got a fair idea regarding that what is null hypothesis and what is actually the alternate hypothesis. In the next video, we are just going to see a little bit more about these things so that you get a more clear idea about the null hypothesis and alternate hypothesis, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous video, we had discussed about the null hypothesis and the alternate hypothesis, right? We had seen that what are these two terms and basically what are the things that we have here and all those things we have discussed even with the one example as well, right? Now, basically today I'm just going to tell you one more example regarding this null and alternate hypothesis as well, and after that we're going to discuss some more things in these things. So let me quickly give you an overview that what we have discussed previously. So we had discussed about the null hypothesis that was actually denoted using H naught, right? And it was a statement about the population that will be assumed to be true unless it can be shown to be incorrect beyond a reasonable doubt, right? And then we had discussed even about the alternate hypothesis, and it was denoted by HA. So basically it is a claim about the population that is contradictory to H naught and where what we conclude when we reject H naught, right? These were two things which we have discussed in the previous video. Let me move on to the same section which I had made it for today, and let me discuss one another example with you all. After that I'll proceed on with the new things, right? Okay, so my example goes here like this. So let's say my question is we want to test, okay, let's say we want to test if college students take less than 5 years to graduate, from college on the average. Okay, that is basically on the average, right? This is the thing. So now basically here what I can just say, according to the alternate hypothesis and according to the null hypothesis, I can just add here that my answer for this question is that null hypothesis, that is H naught. So basically my mu, that is my average, will be greater than equal to 5. Okay, and talking about my HA, that is my alternate hypothesis, that will be basically mu and it would be less than 5. Mu is basically my average. So this is the thing that we can just say from here, that this is the question that we want to test if college students take less than 5 years to graduate from college on the average, right? So this was the idea which we can just add on here with the things, right? Now basically let's say we had just find it out all of these things, whatever I just written. Let's say we had just find it out the alternate hypothesis and even the null hypothesis. Now what comes next? Okay, if I just say right here that since the null and alternate hypothesis, I would just simply write hypo dot, so just assume it as hypothesis only. Okay, since the null and alternate hypothesis are contradictory means crossing with each other, contradictory. So let's say the null and the alternate hypothesis are contradictory, then what I can just say that you must examine evidence. You must examine the evidence to decide if you have if you have enough evidence, to reject the null hypothesis, that is null hypothesis or not. So this is the thing that you need to decide after you have just got out the null hypothesis and the alternate hypothesis values. After this is the thing that you need to decide on, that basically do you have proper evidence to decide that if you have enough evidence to reject the null hypothesis or not, right? So this evidence, actually the evidence which I'm just talking about is it is a form of a sample data. Let me add on that thing also. So the evidence that I was talking about, so the evidence is in the form, so the evidence is in the form of sample data. Evidence is in the form of sample data, right? So after you have just found out all the things regarding the null hypothesis, you had found out regarding the alternate hypothesis, so then you need to decide that do you have enough of evidence to reject the null hypothesis or not, right? So that evidence will be in the form of sample data. Now let me just come down here. So I would just, okay, let me take our color as so as to like change a little bit here. So I would just add on that after you have determined which hypothesis the sample supports, you make a decision. Okay, just 1 second. You make a decision, right? So basically after you have determined that which hypothesis actually you are taking, the sample which you are having, which hypothesis it is actually like supporting. Okay, after that, if you have done this thing, so you had made a decision, right? Now basically there are two options for the decision which you have made, right? Let me just add on those things as well here. So I would just write that thing, that there are two options for a decision. Okay, there can be two options, or you can just say two conditions, or whatever you just want to say. So basically there are two options for a decision. So the very first goes like that. Okay, just let me write it as like this only, right? So it is basically they are reject, if we basically reject the H0. Okay, if the sample information reject H0, basically it means that if the sample info which I have favors the alternate hypothesis, that is alternate hypothesis. Okay, so this is the very first thing which we can have, that basically if they reject H0, and second goes like this, hypothesis, okay, or the second one is that do not reject H0. That is my second condition. Or fail to reject, or even just write as or fail to reject H0. This is also even which we can just write it as another way. So second goes like that, do not reject H0 or fail to reject H0. So this is a decision which can be made if the sample information, that is the sample info, is insufficient. Okay, let me just come down here. Is insufficient to reject. Right, these are the two decisions which can okay, to reject the null hypothesis. Let me write that, the null hypothesis. So these are the two decisions which can be made here, that basically first of all that there are two options for decision. They are basically reject H0 if the sample information favors the alternate hypothesis, or do not reject H0 or fail to reject H0 if the sample information is insufficient to reject the null hypothesis, right? These are the two conditions which can be applied. These are the two statements which we can give here for the decision, right? So after you have determined which hypothesis the sample supports you make a decision. So these were the two options for the decision, right? After that, basically, even I have one table also for this hypothesis testing. Let me just make out that as well. So it is like this here. Okay, let me just come down a little bit like this right here. And now just let me quickly draw one partition type of line here. It is like this, let's say. Okay, let me shift it a little bit here. Yeah, here it will be absolutely. Okay, it's fine. Now I will just take another color. Let's say that will be red for me. Okay, so this is my actually H0 and this is actually my HA. Okay, So my first condition goes that here first sign is my equal, that is my equal sign. Now into this equal sign, if H naught is equal, then HA would be not equal, then HA would be not equal or greater than or greater than or less than. Okay, so if H naught is basically equal, then in that case HA will be not equal or greater than or less than. Right, my second condition goes like greater than or equal to. Okay, so that is great. Okay, just let me even just put out the symbol as well. It will be greater than or equal to. This is a symbol for this, right? Greater than or equal to. So if this is the condition for H naught, then HA will be less than. Okay, then in H it would be less than like this. Okay, and my third condition goes that if H naught is less than or equal to like this, if it is less than or equal to, then in that case basically my HA would be more than. It is like this, right? So I hope that you have got a fair and a clearer idea that basically how we just do out the things here, right? Okay, just 1 second, and let me just include this as well. I know it will, okay, let me not just like remove all these things. Let me put it like this as well. Fine. So basically these are some conditions which apply onto H naught and HA. Right. So I hope that till the point, till now this point, you have got a clear and a very fair idea regarding the null hypothesis and the alternate hypothesis. Even we had seen this thing also, that when you have this categorized that it is null or alternate, after that what you need to do is that, right? After that basically how to make out the decision and all those things basically you have categorized here, right? And even I have just given you some conditions regarding the H naught and HA as well, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now basically today we are going to discuss about the outcomes and the type 1 and type 2 errors. Okay, so previously we had seen about the null hypothesis and the alternate hypothesis. So this is a topic which actually continuous with the previous one only. Now I will be telling you about the outcomes and basically type 1 and type 2 errors which you basically have here. If you basically reject F naught, H naught, if you do not reject H naught, and all those things I will be telling you here, right? So first of all, let me just quickly put out the topic name, and that is outcomes and the type 1 and type. Okay, it's actually this one is actually not written like this. Actually, it's we simply write it is in Roman numerals actually. So it's like this, type 1. Okay, type 1 and type 2. Okay, so outcomes and the type 1 and type 2 errors. This is the topic for today. So basically what I would just say is that basically whenever we just perform a hypothesis test, right, in that basically we have 4 possible outcomes. Okay, in that whenever we just perform a hypothesis test, so in that basically we have 4 possible outcomes. Right, now that all possible outcomes I am going to discuss with you right now, but before that I would be like summarizing all the 4 outcomes into a very short table. Okay, let me firstly write down all the 4 like things which we have, all the 4 ones. After that I would summarize that in the table. Fine, let's go on with the things for you. So my first thing says that if the decision is to not reject, okay, just let me write it the correct spelling. If the decision is to not reject H naught, okay, the decision is to not reject H naught when the fact H naught is true. So that is basically my correct decision. Okay, that is basically my correct decision. So if you have made the decision not to reject H naught, when the fact is that the value for the H naught which you have got, that is absolutely true. So in that case basically you are making the very correct decision. Okay, this is the first thing. Moving towards the second outcome and second condition which we have here. Now the second one is the decision is to reject H0. The decision is to reject the value for the H0 which you have find it out, right? The decision is to reject H0 when in fact the H0 is true. Okay, the H0 is true. So in this case, basically you are trying to make a error. Okay, so first of all, the first thing that comes here is that it is your incorrect decision. Okay, so when decision is incorrect, then there are two cases, either the type 1 error or the type 2 error. Okay, so first of all, this is your incorrect decision, and after that this will lie into your type 1 error. Okay, it will lie into the category of type 1 error. So make sure that whenever you have made a decision to reject H0, and if the fact is that H0 is true, so never make that decision. Okay, never reject H0. So whenever the value for H0 is true, do not reject it. If you are going to do that, in that case basically you are taking your incorrect decision, and that will actually lie under your type 1 error. Okay, what is actually type 1, what is actually type 2, that I would be explaining in a little while. But for now, understand that basically if you are making a decision like this, then it is a type 1 error. Moving towards the very third condition. Now, my third condition says that if the decision actually which you have made, if the decision is to not reject H0, is to not reject H0. If you had made a decision not to reject the H0, okay, when in fact H0 is false, H0 is false. When the value for H0 is false, then also you have made a decision that you will not reject it. So in this case also, this is your incorrect. Okay, just let me write the correct spelling. This is also your incorrect decision. Okay, it is your incorrect decision, and it actually lies under the type 2 error. Type 2 error, not the type 1. Type 1 was the previous one. It actually lies under your type 2 error. Right? So if the decision is not to reject H0, when the fact is that the value for H0 is false. So in that case, basically, you are making the incorrect decision. That means you are making a type 2 error. Okay. And the very fourth condition goes here is that the decision, like the decision which you have made, so the decision is to reject H0 when in fact H0 is false. So now if you have made a decision to reject H0 when in fact the value for H0 is false, so this is actually now your correct decision when the value for H0 is false. So you had simply thought that okay, I would just reject this value. So this is your correct decision. Let me just write that decision here. After that, I have one more thing to let you know. Yeah, so this is your correct decision. And basically, when you have made this type of correct decision, so basically we just give it another name as well. So when you have made this type of correct decision, so we just call it as correct decision whose probability, PRO, simply writing it in short form. So whose probability is called the power of the test. Okay, whose probability is called the power of the test, right? So whenever your decision is to reject H0 and when the H0 value is false, so in that case basically you are making correct decision whose probability is called the power of the test, right? So this is the thing which just comes here for making out the decisions. Now, if I just want to write this thing in a very short way, in a very simple table, if I just want to write this thing. So, I would be just making out one table here, let's say this one. And let me just take one color so that I can just write inside it. Fine. So, here comes my action, that basically what thing I am performing. And here comes my H0 is actually. And here comes again the same thing which is here. Okay, I would just like separate these things with the help of a line so that they actually do not get messed up with each other. Okay, one more line. I just want to separate it like this as well. Right, okay. Now, my first condition goes here that my action is nothing. When let's say my condition here is h naught is actually true, and here I just say that h naught is actually false, right? So action, if I just say do not, if I do not reject h naught, if I do not reject h naught, then if h naught is actually correct, that is if h naught value is actually true, then that is my correct outcome. That is my correct decision which I have made. That is my correct outcome. And if I do not reject h naught and h naught is actually false, let me just write that here as well. H naught is actually, okay, if h naught is actually false and I'm also not rejecting the h naught value, then this is basically comes under my incorrect outcome. Simply write incorrect, not outcome as well, okay? It is my incorrect outcome. Now, second thing comes that if I reject h naught, okay, if I reject h naught, when the value for my h naught is actually true, then in this case basically it would be coming my incorrect decision, and that comes under my type 1 error, okay? And when I reject the value of h naught, and when the value of h naught is false and I reject it, then this comes under the correct outcome, okay? It comes under the correct outcome. And here when I have just written incorrect, when I'm not rejecting the value for h naught, even it is false, so this comes under the condition, and that is basically my type 2 error. I would just write that type 2 here as well, okay? So I hope you just got the idea from this table as well. It is in a very short way that my actions are do not reject h naught when my h naught value is actually correct. So that is my correct outcome, okay? But do not reject h naught when my h naught value is actually false. So that is my incorrect outcome, and it comes under the type 2 error, okay? Second condition comes that I am I'm rejecting the h naught value when the value is true. So this is also my incorrect outcome. So that is my type 1 error. And I'm just saying that reject h naught when h naught value is actually not correct. Then this is my correct decision which I am making. Right. So I hope that basically you have got a fair and a clear idea first regarding that what is a correct decision and what is not a correct decision. So if you are making correct decision, that is well and good, and if you are not making, then basically which type of error you are making, that is type 1 or type 2, or what types of error actually you are making, right? Now let's see regarding the type 1 and type 2 errors which we have here. Okay, let's see that what are actually type 1 and type 2 errors. So let me just come down. I will just tell you in a brief way, and the discussion for it in a detail will be carried on to the next video, okay? Right. So basically, for representing the type 1 and type 2 errors, we have Greek letters, and that are basically alpha and beta. Okay. So alpha basically refers to my type 1 error, and beta actually refers to my type 2 error. First of all, keep this thing in mind, okay? That whenever I'm just writing alpha, so that is basically referring to my type 1 error, and beta is actually referring to my type 2 error. Fine. Now, what I just meant from alpha, what I just meant from type 1 error. So, let me just take a color and write it down here, that what I just can say from my type 1 error. So, you just understand that what is actually the denotions, right? So, I would just not write that again. So, alpha, and that is my type 1. So, alpha, and here I will be writing my type 1, okay? So, okay, I'm just not simply writing type 1, I would just write probability of type 1. Okay, just 1 second. Here it goes, the probability for type 1 error. Okay, probability for type 1 error. So what it is this? It is basically the probability. So my type 1 error goes like it is the probability of rejecting. Okay, it is basically the probability of rejecting the null hypothesis. The null hypothesis. I would simply write hypo, not full. I'm just not going to write here. So when I'm just taking my type 1 error, so this type 1 error is actually the probability of rejecting the null hypothesis when the null hypothesis is true. Okay, this is my type 1 error. My type 1 error says that it is the probability of rejecting the null hypothesis when the null hypothesis is true. Okay, this is my type 1 error which comes here. Moving towards my type 2 error which we have here. So I just told you that type 2 error is represented by beta, right? Let me add on this beta here. and let me just put the probability of type 2. Okay, type, and this 2 goes here. So my type 2 says that it is the probability. So it is the probability of not rejecting the null hypothesis, beta, that is my type 2. It is a probability of not rejecting the null hypothesis when the null hypothesis is false. Okay, is false. So this comes under my type 2 error, which is that the probability of not rejecting the null hypothesis when the null hypothesis is false. So these are the two types of errors which we have here under this outcomes and the type 1 and type 2 errors. So basically these are the two types which you should follow, and H0 is basically my null hypothesis, right? So I hope I made this thing very clear to you that basically what it is and what are the things that come under, what is the decisions and what is the chart actually this means, how to understand it, and how to recognize that you are making type 1 or type 2 errors, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically today we are going to see an example for the type 1 and the type 2 errors, right? You remember that in the previous video we had discussed that what are type 1 and type 2 errors and what is null hypothesis, what are the outcomes for that. These are the things which we have already discussed in the previous videos, right? So basically now today we are going to see some more things regarding the type 1 and the type 2 errors, and other than that we are going to see some examples related to the type 1 and the type 2 errors. Right, so let me just brief you in the previous video that what we had done so that you can just correlate with today's video, right? So in the previous video we had seen the outcomes and the type 1 and the type 2 errors. So the outcomes were that the decision is to not reject H0 when the fact H0 is true. That is correct decision. We had seen about the correct and the incorrect decisions, right? These were the four types that come here, right? So the first one was that if the decision which you have taken, the decision is not to reject H0 when the fact that H0 is true, correct decision. Now basically what is H0? So let me just go on to the one more previous things which we have written here. And yes, here from here we are just getting to know that what we just meant from H0 and what we just meant from HA, right? So H0 was my null hypothesis and HA was my alternate hypothesis, right? H0 was actually referring to my null hypothesis and HA was actually referring to my that alternate hypothesis, right? So you remember that we had discussed these cases. Other than that, basically if I just again move on to the last section like this here. So here basically we were discussing about the H0 and HA, right? We were discussing that what is the correct case, what is the wrong case. So in that basically we got to know that if the decision is to not reject H0, that is basically the null hypothesis when the fact H0 is true. So basically when the H0, that is the null hypothesis, is true and you are not rejecting that thing, so in that basically you are making a correct decision. After that, if the decision is to reject the null hypothesis, that is H0, when in fact the H0 is true, so that is your incorrect decision, and that basically comes under the type 1 error, right? Then next was that the decision is not to reject H0 when in fact H0 is false. So that was also your incorrect decision, and that actually comes under the type 2 error. And the decision is to reject H0 when in fact H0 is false. So that was a correct decision on whose probability is called the power of the test. Right? These are the things, and we had just like summarized that thing in a very short like table, which is this. Now you can just understand on your own. Other than that, we had also seen that what are the denotions for the type 1 and the type 2 error, right? So type 1 is alpha and type 2 is my beta, right? Alpha was my probability of rejecting the null hypothesis when the null hypothesis is true. That is my probability of my type 1. And beta was basically the probability of my type 2, and that says probability of not rejecting the null hypothesis when the null hypothesis is false. Right, now basically I will be just discussing some more things regarding the alpha and the beta, and after that we'll be seeing some examples as well. So we'll just start writing here. Okay, like this, I'll just close it. So I would just write alpha and beta my these H0 and HA, right? This is my hypothesis. So type 1 and type 2 errors, alpha, beta, and type 1 and type 2 errors, right? So alpha and beta should be should be as small as possible. So this is one thing that comes here, that alpha and beta, that is my type 1 and the type 2 error, they should be as small as possible. Now what's the reason for that thing, right? Why basically they should be small? So in that case I'll be writing because they are the probabilities like this, LITI, probabilities of error. So basically these are the probabilities of error, so they should be as small as possible. And next case that comes is that they are rarely zero. So basically you will like rarely be able to see the probabilities of the error as zero. Like the value for alpha and beta, you will rarely be able to see them as zero. So that basically does not comes in manual way, that basically you'll be able to see the zero. So that is not the case here, okay? Now basically we had even seen about the power of test, right? In that basically if you have taken a correct decision, so in that was also where the probability was called as the correct power of test, right? Right now just I have repeated that thing as well. So I'm just writing some things regarding that power of test as well. So I will just write the power of the test. Okay, the power of the test is basically that is 1 minus beta. Okay, if you just want to calculate the power of the test, so that is basically 1 minus beta. So in that case, I would just add on one more thing here, that ideally we want a high power. Ideally we want a high power that is basically that is as close to 1 as possible. Okay, so basically ideally we want a high power that is as close to 1 as possible. So basically increasing the sample size, can increase the sample size can increase the power of the test. Right? So basically what is this, all the things that I have just written about the power of test here. So this is the power of test is 1 minus beta. First of all, if you just want to calculate that thing, so you'll be writing out 1 minus beta. Okay, beta is basically my type 2 error. That is okay. Other than that, basically ideally if you want to increase, if you just want a high power that is close to as 1 as possible, so in that case basically if you just increase the value for the sample size, okay, then in that case the power of your test will also be increased. So as soon as you increase the sample size, the power of the test will also be increasing, right? This is the case that comes with the this power of the test. Right, now we had seen. Now let's see one example regarding the type 1 and the type 2 errors. Let's see that basically if you just get a question like this, how we are gonna write out the type 1 and type 2 errors and how to basically proceed on with that. Right, let me just quickly take a new color so that I can just start writing out the questions as well here. So let me go on with this one. Okay, just 1 second right here. So my question comes here to me. Okay, right here my question comes like this, that basically my question is suppose the null hypothesis, H naught Franks is basically a name, like sample name which I'm just taking. Okay, Frank, Franks, right? This Frank's rock climbing equipment is safe. Now basically this is the hypothesis which I am given here, that suppose the null hypothesis H naught is Frank's rock climbing equipment is safe. This is the hypothesis. Now basically from this question which I am just given here, from this I just need to find out the type 1 error, the type 2 errors, after that the probable alpha, the beta, and all those things I just need to find out and write it from here. Right, so basically it's how to proceed on with this thing. Let's write that here. Let me just come down so that I can just write that properly. Okay, now moving towards my, first of all I'll be moving towards my type 1 error. So that is basically type 1 error like this. Now basically what we had seen in the type 1 error, let me just write it out, write that thing here. After that I'll be explaining you. Okay, so type 1 error is basically, let's say that is basically Frank Frank thinks that his rock climbing, that is rock climbing, Frank thinks that is rock climbing equipment may not be safe, may not be safe when in fact in really, that is basically in the reality, in really is safe, in really is safe. This is my type 1 error which I would be writing from here, that Frank thinks that his rock climbing equipment may not be safe when in fact in really it is safe. Right, this is my type 1 error which comes. Now moving towards my type 2 error. Type 2 error. Okay, let me just come down here. Basically, okay, just 1 second. Let me just quickly take the eraser from here. Let me remove this out from here. Let me just write out the correct denotions for the type 1 and the type 2 errors, right? So let me just take the same color once again. So the 1 is like this and 2 is simply like this, right? This is the correct denotion for writing out the things, right? Now, basically, moving towards my type 2 error. So in my type 2 error, it comes that Frank thinks that his rock climbing equipment may not be safe, may not be safe when in fact it is not safe. It is not safe. So only the difference in my type 1 and the type 2 errors are that in the type 1 error I have just written that Frank thinks that his rock climbing equipment may not be safe, but not but it was when in fact it is safe. And in type 2 error I have simply written that Frank thinks that his rock climbing equipment may not be safe when in fact it is not safe. Only this is the thing that comes between both of these. Right, now if I just want to write out the alpha and the beta thing, so how will I be doing that? So basically, what is my alpha now? So basically now my alpha is probability that Frank thinks his rock climbing probability that Frank thinks his rock climbing may not be safe. In fact, it really is safe. Okay, in fact, it really is safe. Okay, so this is my alpha. And what about my beta? So my beta would be my probability. So that would be my probability, and everything will actually remain safe. Probability that Frank thinks that his rock climbing equipment may be safe when in fact. So I would just not write the whole thing now. Again, repeating that, I would just simply write it after the in fact. Okay, all the things are same as the alpha only. Only little bit difference is made. So in that case, in fact, it is not safe. In fact, it is not safe. Right? This is the thing that comes here. So from here, what we can just conclude, what we can just say from here. So I can just write that here. First of all, what the thing you need to notice. Okay. So notice that in this case, in this particular case which we have taken, notice that in this case the error, okay, the error with the greater consequences is the type 2 error. Okay, now basically how can I just say this thing very surely that it is the greater consequences are for the type 2 error. Now read out the question once again. Suppose the null hypothesis is H0, is Frank's rock climbing equipment is safe. Okay, it is safe. So my type 2 error says me these things only, that Frank thinks that his rock climbing equipment may not be safe, when in fact it is not safe. Right? So this is my probability of type 2 error, that is my beta, which is coming, and from that we can just say that, notice that in this case the error with the greater consequences is the type 2 error. Okay, this is the greater consequences error, right? That I am just occurring it, okay? Because in my question it is basically asking me that the basically the climbing things for the Frank is actually safe, but in my type 2 error it is saying that it is not at all safe. So in that case the greater consequences are with my error, that is type 2 error. Right, so I hope that you have got a clear and a fair idea that how we'll be solving out the questions for this type 1 and type 2 error, and even we had seen some more real things regarding the alpha and the beta. Right, so we'll be continuing these things in the next video. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically, previously in the video, we were discussing about the distribution needed for the hypothesis testing, right? This was the topic that we were actually taking, and we were discussing a lot of things regarding this particular topic, right? We had even started out this topic previously in the video. Let me just go above on the previous site, and let me just once show you that what actually we had done, right? We had deal with that type 1 and the type 2 errors actually. Okay, after that we had seen an example for the type 1 and the type 2, and even we had seen the notations like alpha and the beta as well. We had seen these things as well, okay. Then we had seen the example, and after that we had moved toward this topic, that was distribution needed for hypothesis testing. Okay, this was the topic actually which we were dealing with. Let me just highlight this out so that you can just get the idea that where actually the heading is written, because everything I had written with the same color only, right? So yeah, this is the name for my topic that we had started. We'll be continuing up this topic, and after that we'll be moving towards one new topic, that is assumptions. Okay, right, let me just took out a color here so that we can proceed on. Fine. So we were dealing that we were saying that if you are testing a single population mean, the distribution for the test is for the means, right? And we had set out this formula. We had seen out this formula, right? We had seen this thing previously. Now basically here, now let me let you know another things regarding this. So how we just denote the population parameter? Okay, so the population, I'll just write here that the population parameter is mu, right? Whenever we just want to define the population parameter, so we define it in a term that is mu. Okay, now the estimated value. Okay, the estimated value for mu. Now basically we are going to say that what is the estimated value for the mu that we have defined right now. Okay, so the estimated value that you can just call the estimated value, which I am saying you can just call it as a point estimate. Okay, let me first come down so that I can write everything properly. Right, so I can just even call this as point estimate as well, right? So the estimated value, in bracket it is point estimate for mu. The population parameter mu is basically x bar, okay, x bar, and that is the sample mean, right? The sample mean is denoted by the x bar only, the sample mean. So we have a population parameter, and that is defined by mu. That is the correct thing, right? And what is the estimated or the point estimate for mu? And that is basically my x bar, and x bar actually refers to my sample mean, right? This, I hope that you are clear with this thing. Now one another formula come here, that if you are testing a single population proportion, okay, if you are testing a basically single right here single population, here it is population proportion. We had already discussed that what is single population proportion in the previous videos, right? PROPORTION, like this. So if you are testing a single population proportion, comma, the distribution for the test, I would just write the distribution, right here. So the distribution for the test is, okay, the distribution for the test is for proportions or for proportions or percentages, okay. So here goes the percentages. Fine. So if you're testing a single population proportion, then the distribution for a test is for proportions or percentages, right? So here my formula goes a P dash. okay, P dash is approximately equal to N, okay, and into the bracket it is a small p, comma, okay, just let me write it like a small p as well, okay, small p, make sure this is small p, okay, do not consider it as a capital one. So small p dot q upon n, right? This is the formula actually we follow if you're testing a single population proportion in that case, right? Now what is the small p here that I am again and again saying, I am again and again defining that what is the small p here. Well, let me write out that thing. So the population the population parameter is p. Okay, meter right here is p, right? The small p which I'm just defining here again and again. So this is small p, this one and this one. Okay, these both constitute the population parameter. We define the population parameter as a small p. Right, now let's define about the estimated value. So the estimated value, that is basically the point estimate, right? The estimated value, or I would just write in the bracket point, in the bracket is point estimate, right? Estimated value or the point estimate for small p, that is my population population parameter is p dash multiplied by p dash, which is equal to x upon n. Where now what are these x and n values, right? So we had already seen this thing once, but again let me quickly repeat that here. Where x is the number of successes. Remember that we had seen this thing in very detail in the hypothesis testing as well, that what are the x and what is the n. So x was my number of successes, and what is the n? And n is the sample size. So n always remains the same, only does not differentiates whatever topic actually you are studying, right? And n was always a sample mean from the very starting of the statistics, and at the last of the till the statistics, n will always be remain the sample size only, right? So this is about what I can just say about the let me scan above. Yeah, distribution needed for the hypothesis testing. So these are the two ones. Okay, these are the two which I had just mentioned here. First is this x bar approximately equal to n. Okay, just let me close this as well. And mu x comma sigma x upon under root of n, or we can just say it as TDF, right? And another one is p dash approximately equal to n, and into the bracket it is p comma under root of p dot q upon n. Right, so these are the distribution which we have here, right? Now let's move on to a new topic, that is basically the assumption. Right, now basically we'll be seeing that when we just do the hypothesis test for a single population mean. So like when we just like try to do a hypothesis test for a single population mean using a student state distribution, then basically what are the fundamental assumptions that need to be met in order to basically work off the two properly. Okay, so basically so that my test works properly, so what are the assumptions that I need to make here when I am performing a hypothesis test of a single population mean using the student state distribution, right? So let me just start off with this topic for now. Okay, let me just put out a heading here for the new topic, and that is I will be starting here with this color, and that is basically assumptions. So ASSUMPTIONS. Here goes my new topic, and that I have assumptions, right? So we'll be understanding about this topic, that what does it mean and how we just make out the assumptions, what are the assumptions that we need to make here when we are dealing with the student seed distribution and the hypothesis test of a single population, right? Okay, fine here. So, okay, this one another second right here. I'll be just taking out a new color, and let's start writing the things for now. Here goes the pen, and here goes the color. Start on. Right, so I'll just start writing that when you are, okay, sorry, not when you perform a hypothesis, okay, when you perform a hypothesis test of a single population, I'm just simply write POP and dot. That actually means the population only. Okay, so when you perform a hypothesis test of a single population mean, I will just put out a denotation, and that is actually mu. Okay, Right, let me come down. So when you perform a hypothesis test of a single population mean, that is mu, using a students t distribution. So basically when you try to perform the hypothesis test of a single population mean, that is basically denoted by mu using a students t distribution, and basically students t distribution is often called as a t-test as well, right? We had already seen this, and so I'm just not going to write that thing as well here, but quickly revise that students t distribution is always also called as a t-test, right? Okay, so when you perform a hypothesis test of a single population mean mu using a students t distribution, so I'll put out a comma here. I would start writing that there are fundamental assumptions, PTIONS, right? So there are fundamental assumptions that need to be met in order for the test to work properly. And what are those assumptions actually that need to be met? Okay, just let me write out the correct spelling right here. So properly, I've put out a full stop here basically. So your conditions are first that your data, the data which you're having, so your data should be a simple random sample. The very first thing that you should have, that your data should be a simple random sample. Okay, that comes basically from a population that is approximately, so I would just add that thing here, that is approximately. Okay, let me come down first of all. So your data should be a simple random sample that comes from a population that is approximately normally distributed. Okay, distributed. Fine. After this basically you use right here. So you use the sample standard deviation. Use the sample standard deviation to approximate the population standard deviation. Let me just come down. So you use the sample standard deviation to approximate the population standard deviation, right? So this is the condition that should be met. Let me just go about take the scroller so that I can just like show you the thing. Just one second, right here. Okay. So now my assumption is that when you perform a hypothesis test of a single population mean mu using a student t distribution, so there are fundamental assumptions that need to be met in order for the test to work properly. So the first is that your data should be a simple random sample that comes from a population that is approximately normally distributed. So you use the sample standard deviation to approximate the population standard deviation, right? So this is the condition that should be met to perform the hypothesis test of a single population mean mu using a student's t distribution, right? Now basically there is some another as well, so that we will not be discussing right now, that we will be discussing in the next video. But for now understand that this is the assumption that should be made, the first assumption, okay? And above that we had seen some distribution needed for the hypothesis testing, some formulas and some things we have already seen, right? So basically I hope that you had got all the topics which we have discussed today. You have got a fair and a clear idea regarding the distributions and regarding the assumptions as well, right? So we'll be seeing some more things in the next video. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically, we were discussing about the assumptions in the statistics, right? We had seen a little bit of things regarding the assumptions, that basically what assumption you should take and basically what you can perform and all those things, right? We had seen one condition as well. Now today we'll be proceeding on with this particular topic only. We'll be seeing all the assumptions which are here, right? So first of all, basically let me just revise out that what we had actually done in the previous video, then I will be proceeding on here, right? So basically we had seen that when you perform a hypothesis test of a single population mean, that was mu, right? We had given that symbol as mu, we denoted with the symbol mu, right? So when you perform a hypothesis test of a single population mean mu using a student's t distribution, there are fundamental assumptions that need to be met in order for the test to work properly. So the assumptions which were basically there, that was that your data should be a simple random sample that comes from a population that is approximately normally distributed. You use the sample standard deviation to approximate the population standard deviation, right? This was that we had actually taken, right, that it should be normally distributed, and after that you use the same sample standard deviation to approximate the population standard deviation, right? Now basically we can just have a note here that whatever the sample size, basically your sample size is sufficiently large, then the t-test will also work even if the population is not approximately normally distributed, right? So if your sample size is sufficiently large, so in that case your basically t-test is basically the concept which you are already studied, right? So t-test will actually work, it will even work if the population is not approximately normally distributed, right? As the other condition was that it need to be approximate normally distributed, right? But if your sample size is enough large, in that case this can even work as well. Okay, so this was the thing that we have discussed. Now basically I'll be proceeding on with some other things as well. So let me just take out a color from here, and right here I'll just come down first of all. So okay, right here I would be start writing. So it comes that right, so when you perform a hypothesis test, when you perform a hypothesis test, when you perform a hypothesis test of a single population mean, so basically when you are performing a hypothesis test of a single population mean, that is mu, right? Mu is a symbol for that. So using a normal distribution, using a normal distribution, I would just write here distribution. So when you perform a hypothesis test of a single population mean, that is mu, using a normal distribution, so what we do, you actually take, so you take a simple random sample. You take a simple random sample, right? You take a simple random sample from the population, right? So we just take a simple random sample from the population, right? And I would just come down. One more condition actually met here. So that is the sample, the population you are testing, okay, just let me write that clear. Right, yes, the population that you are testing is normally distributed. It is normally distributed. Right here, it is normally distributed, and okay, or the second thing is that your sample size is sufficiently large, or your sample size is sufficiently large. This was the thing which I have mentioned above as well, right? When I was just telling you a note for that. So what I just mentioned, that if the sample size is sufficiently large, then the t-test will work even if the population is not approximately normally distributed, right? So like related to that only, I have just written out the second thing here, right? Now basically what do we know? So you know the value of You know the value of the population Let me come down. First of all, so you know the value of the population standard and deviation. Right? You know the value for the population standard deviation. Let me come above. First of all, let me take the scroller from here. Right here. Fine. So my condition says that when you perform a hypothesis test of a single population mean mu using a normal distribution, you take a simple random sample from the population. The population you are testing is normally distributed or your sample size is sufficient large. You know the value of the population standard deviation. Right? Second thing comes. Now this is the another thing that was above one was we have discussed about the hypothesis test of a single population mean. Now again we are just going to do that, but we are going to discuss about the hypothesis test of a single population proportion. Above was the mean, now is the proportion, right? So I will just add here that when you perform a hypothesis, right here. So when you perform a hypothesis test, of a single population proportion, here comes the proportion, right? So when you perform a hypothesis test of a single population proportion, that is P, denoted by P, right? You take a, what do you take? So you take a simple random sample. You take a simple random sample. You take a simple random sample from the population. This is what you do, right? You take a simple random sample from the population. Now, what is the condition that you must meet? So, you must meet the condition. Let me come down. Right, you must meet the condition that is basically condition for a binomial. You must meet the condition for a binomial distribution. Right, so when this type of case actually comes, that when you are going to perform a hypothesis test of a single population proportion, then in that case you must meet the condition for the binomial distribution, which are there as a certain number of n of independent trials. Okay, this is the condition that you should meet, that independent trials. Now, what will the outcome of that? The outcome of any trial. You take any trial, okay? So the outcome of any trial are success and the failure, right? So outcome for the any trial are successes and failures. Let me come down. So the outcome for any trial are successes and failures, right? And each trial has the same probability of success, okay, of a SUCC, of a success, and that is actually P, right? So and each trial has the same probability of a success, that is P. Okay, this is the thing. Right, now basically let's define the shape as well of this. So the shape of the binomial distribution. So right here, distribution. So the shape of the binomial distribution needs to be now this needs to be similar to the shape of, it needs to be similar to the shape, it needs to be similar to the shape of the normal distribution. To the normal, okay, just let me erase this normal first of all and let me come down. So the binomial distribution needs to be similar to the shape of normal distribution. These are the conditions which should be met. Okay, normal distribution. Now, to basically to ensure this, we have to ensure this particular things. To ensure this, we have the quantities NP and NQ. NP and NQ both must both be greater than 5. Okay, this is the condition that I will just write here. NP should be greater than 5 and NQ should also be greater than 5 so as to get the shape of a normal distribution. So in that case, the quantities which are NP and the NQ. Okay, let me just write that Q above. I have missed that thing here, right here, and let me take the color. Okay, just 1 second. Let me take the similar color again which we were taking. So here goes the NQ right here. So to ensure the quantities NP and NQ, okay, both must be greater than 5. NP should be greater than 5 and NQ as well should be greater than 5. Right, then basically we have approximately normal distribution. We have that mu is equal to P, comma, for sigma we have under root of P into Q upon N. Right, this is the thing that we have. And what is the value for P? So P is equal to Q minus 1. Right, so these are the conditions, these are the assumptions which we actually need to make while defining the thing. Let me again take the scroller and tell you the last one which we have actually written here. So when you perform a hypothesis test of a single population proportion, that is P, you take a simple random sample from the population. You must meet the condition for a binomial distribution which are there as a certain number of n of independent trials. The outcome of any trial are success and failure, and each trial has the same probability of a success, that is P. Then the shape of the binomial distribution needs to be similar to the shape of normal distribution, and to ensure this thing, the quantities NP and NQ must be greater than 5, right? And here are the formulas which actually constitute these assumptions. Right, so I hope I just made this thing very clear to you that how we take the assumptions, which assumptions to take at what particular place. Right, so this is regarding the hypothesis test only. Now I'll be moving towards some another topic in the next video. Right, so this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically today we are going to discuss about the rare events in the statistics, right? Let me just take out a color from here and okay, let me just take out this particular color as well. So my topic for today is rare events, right? This is the topic that today we are going to deal with. Now this topic is actually a little bit of correlated to the previous topic which we have already seen, and that is for me as assumptions, right? We had already seen about the assumptions, right? Let me do one thing, because this is in continuation, it is a little bit of correlated topics. Let me give you an overview regarding the assumption which we have actually dealt with, right? Right, let me begin at here. So when you perform a hypothesis test of a single population mean mu using a student distribution, they are fundamental assumptions that need to be met in order for the test to work properly, right? First of all, what was the assumption? That your data should be a simple random sample that comes from a population that is approximately normally distributed. Please listen to me very much carefully. Please see on the which words I am giving a little bit of stress, because those words are actually important to be listened, right? So your data should be a simple random sample that comes from a population that's approximately normally distributed. And you use the sample standard deviation to approximate the population standard deviation. When you perform a hypothesis test of a single population mean, that is mu, using a normal distribution, you take a simple random sample from the population. Okay, now if the population which you are testing is normally distributed or your sample size is sufficient large, you know the value for the population standard deviation, right? This is the thing that we have seen in the assumptions. Next one which we had made was when you perform a hypothesis test of a single population proportion, that is P. Previously we had dealt with the single population mean, that was mu. Now we are dealing with a P, single population proportion, that is P. You take a simple random sample from the population. You must meet the condition for a binomial distribution which are there as a certain number of n of independent trials. The outcome of any trial are success and failure. This thing we already know, and each trial actually has the same probability of a success, that is P, right? These are all of the things that we have already seen, right? And these were the formulas that we had seen, that mu is equal to P and sigma is equal to P dot Q divided by N. So P is equal to Q minus 1. Right? These are the things, this all were the things that we have actually seen. Now we'll be talking regarding the rare events, that what are these rare events and how we just use them, what are the things that we need to keep in mind, all these things we are gonna take here, fine? So, okay, it's right here. Let me start here. Let me start while writing only that suppose, okay, suppose you make an assumption, okay, suppose you make an assumption about a property, about a property of the population, Suppose you make an assumption about the property of the population. Okay, now what is that assumption actually for? Let me put out the bracket and let me put out that this assumption is the null hypothesis. You remember we had already discussed regarding null hypothesis in a very detailed way, right? In the previous videos we had seen. Suppose you make an assumption about a property of the population, and this assumption is the null hypothesis, right? Then what do you do? Then you gather sample data. Okay, just one second. Then you gather sample data randomly, right? Then you just gather out some sample data randomly. After that, if the condition goes that if the sample has properties, if the sample has properties that would be very unlikely to occur, very unlikely to occur if the assumption is true, right? Let me come down right here, that if the assumption which you have made, if that is true, if the assumption is true. One second, let me go above first of all. Let me hold out the cursor, fine. Now, then you gather sample data randomly, right? If the sample has properties that would be very unlikely to occur if the assumption is true, right? Then what would you do actually? Then you would conclude that your assumption let me come down. Then you will conclude that your assumption about the population, is probably incorrect, right? Is probably incorrect. This is what you will actually conclude from here, that your assumption about the population is probably incorrect, right? Now, what you just need to remember from here, one thing that you should remember always, let me just write out that thing as well. I just not speak, let me write out. Remember that your assumption, the assumption which you are actually making, remember that your assumption is only an assumption. Remember that your assumption is just an assumption. Fine. Remember this thing always, that your assumption is just an assumption. It is not a fact. It is not a fact, and it may or may not. It may or may not be true. It may or may not be true. Remember, please remember always this thing, that your assumption is just an assumption. It is not a fact that it may or may not be true. Okay, but your sample data which you are taking actually, and the real and the data are showing that the fact that seems to contradict your assumption. Fine, this is the thing that you should keep in your mind. Fine. Okay, I hope that you got this thing first of all. Now let me just take out a very simple example here. Let's quickly take out that example. Let me come down. Okay. Example. Let's say. Okay. I'll be taking a simple oral example that I'll be just communicating with you. Okay. Let's say Didi and Ali. These are the two names. Let's say. Okay. Let's say Didi and Ali are at a birthday party. Okay. They are at a birthday party of a, let's say, very wealthy friend actually. Okay. That friend is very rich. So Didi and Ali are at a party of that particular friend. Okay. They hurry to be just going to the line in the first and to grab up the prize. Okay, and they are having a tall basket there, so they just like, let's say they just go there and hurry to grab up the prize, right? Okay, now basically they were not able to see inside that basket, inside a tall basket. Why? Because that was blindfolded. Okay, they were not able to see inside that basket because that basket was actually blindfolded. Now there were actually 200 plastic bubbles. Let me just write out some important things that were actually, there were 200 plastic bubbles, okay, into the basket. Fine. So this was the thing that Didi and Ali were told, that there is only one with a $100 bill. There was only one bubble into that one, only plastic bubble that was having a price as $100. This thing Didi and Ali, both of them were told, right? Now first of all, let's say now condition apply that Didi, let's say Didi was the first person who reached into the basket and pull out a bubble, right? Now her bubble contains a $100 bill. Okay, Didi was the first one who just went into that basket and pulled out a bubble, plastic bubble, and yes, that was the $100 bill one, right? Now for the, what is the probability for happening this particular thing, right? What is the probability? I mentioned that there was a big basket that was actually blindfolded, and inside that basket 200 plastic bubbles were put on, and that one single bubble was having a $100 bill, right? So first one was a Didi just put out her hand into that particular basket and she took out a plastic bubble. Now I need to find out that what is the probability that her bubble contains a $100 bill. So what are the total plastic bubbles? We are having 200, right? So this can be 1 upon 200 because 1 has been taken out from there. So my probability is 0.05, that the Didi she picked up the plastic bubble that is having the $100 bill, right? No. So basically what is this? This is so unlikely, right? So basically what was Ali hoping? Ali was hoping that whatever the two of them were told is wrong, and there are more $100 bills in the basket. Okay? This is the thing which actually comes into the mind, that let's say she just put on the hand in the basket, that $100 bill come. So now Ali was thinking that this is so much unlikely, right? This is so much unlikely. There were many of them, but the two of them were told wrong, that there is only one $100 bill. So there can be more than even $100 bill bubbles into the basket, right? So this is a rare event which has occurred. Okay, so what is Ali doubting? Ali is actually now doubting at the assumption that only $100 bill plastic bubble is in the basket, right? This is Ali. This is actually a rare event which has occurred. Let me come down. Fine, this is actually a rare event. This is actually a rare event that has occurred, that Didi getting the $100 bill, right? Let's say that she put out her hand into that basket for the first, and for the first only that she got out that $100 bill. So yeah, that is an unlikely assumption, right? Now here can be a doubt as well that except a one single $100 bill, there can be many of them, right? So that is that they were told wrong about this particular thing, because at the very first time when she puts out her hand into that basket, it is very rare to come out at the very first time she put out the hand into that basket, and it is very rare that this $100 bill would come, right? So this is actually what is called a rare event. Okay, now from that, all the doubts are regarding the assumption that only $100 bill is being in the basket, right? So Ali actually what Ali does now, he doubts out the assumption that only $100 bill is being in the basket, right? So this was the example which we have taken for the rare events. I hope that you got this idea regarding this like example which I have taken, right? That how we can just say that it is rare event. Now firstly she put out the hand in the basket, and at the very first time only she just got out the $100 bill. Yes, that is a rare event, because that occurs very much rarely that you have put out the hand into that you are the first person, you have just put out the hand into the basket and you just got out the $100 bill. That is a rare one, right? So this is actually what is called a rare event. Let me put out the definition once again. That suppose you make an assumption about a property of the population, okay, then you gather sample data randomly. If the sample has properties that would be very unlikely to occur if the assumption is true, then you would conclude that your assumption about the population is probably incorrect. And the same thing was done by Didi and the Ali, right? So I hope I just made this topic very much clear to you regarding that what are the rare events and how we just say that a particular event which is occurring, that is a rare event, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. Now basically today we are going to discuss about the decision and the conclusion in the hypothesis testing. Right now this will be the last topic for the hypothesis testing. After that we are going to practice some of the questions, but to the theoretical part, the decision and conclusion is the last part for this hypothesis testing topic. Right, let me just first of all go on to the previous slide where we had just studied about the rare events a little bit, right? The last topic which we have discussed was the rare events. Now what we had discussed about in this particular topic, so that we had made an assumption about the property of the population. Then basically what you do, you gather out the sample data randomly, and if that sample data has properties that would be very unlikely to occur if the assumption is true, then you would basically conclude that your assumption about the population is probably incorrect, right? The assumption, I just mentioned that as assumption when you are just saying this thing, so it is actually an assumption only, it's not a fact, okay? It may be true or it may not be true. This is a thing that can come here in between, right? Other than that, we had taken an example in which we had studied about the rare events, right? Now we're just not going to repeat out that example because that was a quite large example. So if you just want to have a look over that, you can just again go to the previous video. Right, so now today's topic that we are going to discuss today, let me just put out the heading here, that is decision and conclusion. Now after performing out the hypothesis testing, after finding out the rare events, after doing all of these things, the main thing that comes here and that stays here is the decision and the conclusion, right? Now how to make out that what is the decision that we should take for this particular question and how to conclude out that particular question, right? This is what we are going to see now. Okay, let me just take out a different color, and so that we can just start writing out here. And okay, let me go on to this one. And here basically we go. Right, now basically what I would just do, I would just start writing that a systematic. So basically for making a decision, we have several conditions that I'll be just telling you right now only. Okay, so a systematic way to make a decision, okay, just let me write out the correct spelling for the decision. So that is like this. Okay, so a correct way to make a decision of whether, now what is the condition for which we make out a decision? We make out a decision that we need to reject the null hypothesis, or basically what we just need to do with that. This is what we make out a decision for, right? So a systematic way to make a decision of whether to reject or not reject. Okay, let me write that reject downside, or not reject the null hypothesis, because this is the only case where we just make out some decisions, right, in the null hypothesis, because in this only we need to decide that do we need to reject or we do not need to reject, or what we need to do out here, right? So a systematic way to make a decision of whether to reject or not reject the null hypothesis is okay, let me come down so that I can just get a blank space for writing. Fine. So this is to compare the p-value or you can yeah, it is basically for comparing out the p. Let me remove out that or from here. So yes, on basis of this only we just make out the decision, right, that we compare out the null hypothesis with the p-value, and then only we just make out a decision that whether we need to reject that out or we do not need to reject that out, right? This is what we actually do here. So to compare the p-value, after this, okay, now I'll be putting out some conditions here. Now before that, there is one term which I just want you to introduce, and that term is actually preset. That is preset. So let me write that preset, and let me even put out a highlighter here so that this you can get to know that is the topic which we are discussing. Right, now this is one term which comes here, that is preset. Now after this I will be explaining you that what does this preset actually mean here, right? So preset, what is it actually? So I would just write here a preset, P-R-E, that is P-R-E, a preset. We just call it as alpha, we just denote it by as alpha, okay? So a preset alpha is the probability. I'm simply writing the P-R-O-B and then dot. This is actually probability. I'm just simply writing out the short form, okay? So a preset alpha is the probability of a type 1 error, that is basically rejecting the null hypothesis when the null hypothesis is true. This was a type 1 error, right? That rejecting the null hypothesis when the null hypothesis is true. This was what about the type 1 error, right? So a preset alpha is the probability of a type 1 error. It may or may not be given to you. It may or may not be given to you at the beginning of the problem. So basically here the preset which we are talking about, that is an alpha. That is basically alpha is the probability of a type 1 error, right? That we actually know. So that probability is even called as a preset as well, right? Now second thing comes that it may be given or it may not be given to us in the beginning of the question or beginning of the problem which we are actually getting here. Right, now we just come down here and let me just put out the ways for making out a decision. Right, I would just write that when you make a decision, decision like this, okay. So when you make a decision to reject, when you make a decision to reject or not reject H0, that is basically my null hypothesis, right? So do as follows. So whenever we just make out some decision to reject or not to reject, in that case I mean we had some conditions, right, that we actually put out here. So let me just define out that conditions a little bit here, that we put out that if do we just want to reject out the null hypothesis or we do not have to do, right? Let me come to a new line here and let's start writing out. So my first point goes, put out the first point and let's write here that if A, sorry, that is not A, that is my alpha. Okay, this is the alpha. You can just call it as type 1 error or you can just call it as preset. Okay, so if alpha is greater than the p-value, okay, my first condition, that if alpha is greater than p-value, then reject H0. Then in that case, reject H0. H0 means my null hypothesis, right? This is my very first condition that comes into role, that if alpha is greater than the p-value, then reject out the H0, my null hypothesis, right? Now, what is the result of the sample if it is get some condition like this? So I would just write the result. Okay, the result of the sample data, the result of the sample data are significant. Okay, if you just get out some sample data like this, the result for that sample data are significant, right? Now, there is basically sufficient evidence to conclude that H0 is an incorrect belief that the alternative hypothesis HA may be correct, right? Let me write out that thing because it is a very important line for this particular topic, right? Let me write out that thing. So, I would just write here the sufficient evidence to conclude sufficient evidence to conclude that H0 is an incorrect belief that H0 is an incorrect belief that H0 is an incorrect belief. So basically and then we have the null hypothesis and we have secondly the alternative hypothesis as well, right? And then the alternative hypothesis that is HA. H and here A, right? And then the alternative hypothesis HA may be correct, right? This is the first condition that actually applies out here, right? This is the very first thing that applies out here. Let me just take the scroller here and let's see it. So when you, if alpha is greater than p-value, reject H0. The result of the sample data are significant. The sufficient evidence to conclude that H0 is an incorrect belief and then the alternative hypothesis HA may be correct. This is the very first condition. Okay. Right. Now let's come to a new line and now here my second condition starts out. So my second condition starts that if alpha is less, let me write alpha first of all clearly. If alpha is less than or equal to p-value, my second condition goes like this, okay? That if alpha is less than or equal to p-value, then do not reject H0. Okay, if this is the condition, then do not reject H0. Now, basically, the result of the sample data are not significant. In the above condition, they were significant, right? But here in this condition, the results of that are not significant. So basically, there is insufficient evidence to conclude that the alternative hypothesis, that is HA, may be correct. So I would just write the last line only, okay? Insufficient. So basically, there is insufficient. STFFI right here. So insufficient evidence to conclude insufficient evidence to conclude that the alternative hypothesis hypothesis. So if alpha is less than or equal to the p-value, do not reject H0. So in that case, it can be concluded that insufficient evidence to conclude that the alternative hypothesis, that is HA, may be correct. Right? This is the second the second decision which we actually have. Right? So, now what happens when you do not reject out the H0? What actually happens, right? So when you basically do not reject the H0, it does not mean that you should believe that H0 is true. Please listen to my words very much carefully because I'm just not going to write out that thing. So whenever you do not reject H0, so in that case, it does not mean that you should believe that H0 value is true. It simply means, basically, the condition which I mentioned, that simply means that the sample data have failed to provide the sample data has failed to provide the sufficient evidence to cast serious doubt about the truthfulness of H0. Okay, it's not the case that if you are not basically, if you do not reject the H naught, so H naught is true. No, it's not at all true. The only condition can be that if H naught is true, so in that case you should simply mean that the sample data, the data which I have taken actually, that has actually failed out to provide the sufficient evidence to doubt about the H naught. Okay. This is all. It does not mean that H naught value is actually true. No. I told you that thing 2 times. I'm just not going to repeat that third time. Okay. Just listen to my words very carefully as I mentioned in the starting as well. What conclusion you can give out here? What conclusion we can give out from here? So conclusion is after you make your decision, after you make out your decision, write a thoughtful conclusion, write out a thoughtful conclusion about the hypothesis in terms of the given problem. Right, this is the conclusion which you can make, that after you make your decision, write out a thoughtful conclusion about the hypothesis in terms of the given problem. This is how you should write out the conclusion. Right, so this is whole about decision and conclusion, right? That is systematic way to make a decision of whether to reject or not reject a null hypothesis is to compare the p-value. That is, we have even preset as well. So a preset alpha is the probability of a type 1 error. It may or may not be given to you at the beginning of the problem. When you make out a decision to reject or not reject H naught, do as follows. If alpha is greater than p-value, reject the H naught. The result of the sample data are significant. The sufficient evidence to conclude that H naught is an incorrect belief, and then an alternative hypothesis HA may be correct. And if alpha is less than or equal to p-values, do not reject H naught. Insufficient evidence to conclude that the alternative hypothesis HA may be correct. And the conclusion which you can make is, after you make your decision, write out a thoughtful conclusion about the hypothesis in terms of the given problem. Right? This is how you should do the thing. This is how you should proceed with the things in making out the decision and in making out the conclusion. Right? I hope I just made this thing very much clear to you, how to make out the decisions and how to make out the conclusion. Right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now today we'll be discussing about the summary of all the formulas which we have actually seen in the hypothesis testing. Right, we'll be dealing with all of those formulas, and like the concept which you should remember, we'll be dealing with all of those things which we have covered in the hypothesis testing. Right, so let me just write out here the heading for today, and that is actually the summary of, and we have the formula. So basically there were not too many formulas in this particular topic, but yeah, there were too many concepts which we need to keep in mind while doing out the questions. Right, there were many of the concepts which were very important, which we should remember while doing out the questions and while solving out the questions. Right, so we'll be solving out all of those, seeing out all of those formulas today within this particular video, so that you can just make out a summary of all the ones and you can just keep all of those things at one particular place for you to study. Right, so this is what we are going to do today. So okay, let's get started here. Okay, I would take a color, let's say this one, fine. Let me start out from here. So you know that we had seen out a table, right, in which H naught and HA. H naught was the, basically let me write here H naught and HA, right? This was the null hypothesis and this was the alternate hypothesis. Let me just write out that thing as well, because we are doing a revision of the previous thing, right? So this was the null hypothesis and this was the alternate hypothesis, right? H naught was the denotation for the null hypothesis, HA was the denotation for the alternate hypothesis. So basically we had seen about one of the tables in which we had done out this null hypothesis, and we had compared out many things, right? We had straightened out many things and even we have compared out. So let's study that through a table only. So yeah, let's study the same thing through a table only, right? Let's do that thing here. Fine. So what I would just doing here is that I would be making some columns. Now, okay, I would be making 4 columns right here. So let's say, okay, first column would be a little small. Let's say this is my very first column which I am actually making. And okay, after that I would be taking it's one of my second column, let's say like this. And I would be wanting 1/3 column as well. Let's say this one is 3rd and 4th. Fine, let's say these are the columns which I have actually made out here. And now what I would just doing here is that I would be putting one another line so as to put all of my headings. Let's say this is the table. Fine. Okay, now let's see that basically what we need to do inside this. So I would just take out a color and let's start writing the important things which we have here. Fine. So here basically I'll be putting out the conditions, that is basically I would be taking out here if and if H naught has, this is my first one on which I'll be dealing with. Okay, if H naught has, now if H naught has basically equal sign like this, then okay, if H naught has, then we have one equal, then here we had one another, that is greater than or equal to, and the sign is like this, right? This is sign which we actually have, that is of the greater than and equal to, right? Now here for the third one we have less than or equal, to. So in this case my sign is like this actually. Fine. This one is for my H naught. Okay, this one is for my H naught. Now next would be for my basically, that would be for my HA, right? Okay, I would just write then HA is. Okay, then HA is. So here basically that will be not equal to or greater than or less than. We have 3 options. I would just write not equal to, or we have greater than, or we have less than. Fine. And now second case goes here like that, if HA if H naught is greater than or equal to, then in that case HA would be less than. Okay, and now my third case goes that if H naught is basically, if H naught has less than or equal to, so in that case my HA would be greater than. Fine. So these are the conditions, these are the things which go upon here, that if H naught has equal to, then HA would be not equal to or greater than or equal or less than. Fine. If H naught has greater than or equal to, then HA would be less than equal to. Sorry, only less than, not equal to. And if H naught has less than or equal to, then HA would be greater than. Right, this is the whole table which I just wanted you to explain. Right, now according to this only we just set out the values for the, we just set out the P's, we just need to reject it or not reject it. According to this only we just see out all of these things. So let me just write out that things as well. So I would just write that if alpha is less than equal to P value. Okay, if alpha is less than equal to P value, then basically then what we need to do is that then do not reject H naught. If this is a condition which is actually satisfying, that if the value for alpha is less than the P value, is less than or equal to P value, then in that case do not reject out the H naught. And second one goes that if alpha is greater than the P value. Okay, if alpha is greater than the P value, so in that case then okay, put out a comma and I could just add here that then I would just write then reject H naught. Okay, so if alpha is less than or equal to the P value, so in that case then do not reject H naught. So basically if the alpha is greater than the P value, so in that case reject out the H naught. So let me just take out and put out the dot here. Fine. Now this is the another condition which actually appears here. Fine. After that, what we can just do with the alpha. So alpha is, okay, let me just come down first of all and let me start it out here as well. Okay. So what is alpha? Alpha is basically, it's the value. Okay. So I could just write that alpha is preconceived, conceived. Now what does I mean, what do I just actually mean from this preconceived word? So alpha is preconceived. It means that its value, okay, its value is set before the hypothesis test starts. Okay, before the hypothesis test starts. So here we go like this. Okay, so alpha is basically a preconceived value. So it means that the value for alpha is set before the hypothesis test starts. Right now, how do we just calculate out that p-value? So I would just write that the p-value is calculated. The p-value is calculated from the p-value is calculated from the data. Okay, so the p-value which we are having, that is actually calculated from the data. Okay, now after that, let's see that what are alpha and beta here for the type 1 and the type 2 errors. Right, so let me just take out a new color because we are starting out a new thing here. So let me just take out some, okay, let me go from here and let me choose out something from here. Okay, let's go on with this one. Fine. Now I will be discussing about alpha and beta here. Okay, alpha and beta. Now what is alpha here actually? Alpha is basically the probability. I would just write here probable. Okay, let me just remove out this everything and I will simply write probability in the short form. Okay, so alpha is basically my probability of a type 1 error. Okay, so alpha is the probability of the type 1 error. Okay, now what is this type 1 error actually is? So that is actually, so I would just write the whole thing, that probability of rejecting a null hypothesis, when the probability of rejecting the null hypothesis when the null hypothesis is true. Okay, this is the thing that you should keep in mind, that the probability of a type 1 error, what is that? The probability of rejecting a null hypothesis when the null hypothesis is true. That is what we call as a probability of a type 1 error, and we just denote it from the symbol that is alpha. Okay, after this, what is about the beta? So beta is basically my probability of a type 2 error. So I would just write that same thing, probability of a I would just write a type 2 error. Okay, so beta is my probability of a type 2 error. Now in this type 2 error, what actually comes, I could just simply write here that probability of rejecting the null hypothesis, I would just write it out like this. Okay, so probability of rejecting the null hypothesis when the null hypothesis is false. Okay, so this is what we call as the probability of a type 2 error, that the probability of rejecting out the null hypothesis when the null hypothesis is actually false, right? And that is basically denoted by the symbol that is beta, right? I hope that first of all you just got this much of idea. Now after that, basically what we'll be talking about, okay, now I would just write one more important thing here. I would just write that if there is no given preconceived alpha, okay, then basically what I just told you from the preconceived word, so that was that the value is set before the hypothesis test starts, right? So if that value for alpha, if there is no given preconceived alpha, it means that if before the null hypothesis the before the null hypothesis, if the value for alpha is not set out, then in that case, then use the value for alpha as 0.05. okay, So if the value for alpha is not set previously the null hypothesis, so in that case you can simply use out the value for alpha, that is 0.05. Right. Now after this I'll be giving you a short summary on the different types of hypothesis test actually. Okay. So I will just write it. Fine. So now my next topic of discussion would be types of hypothesis test, right? We'll be discussing about the different types of hypothesis test. Okay. Now moving towards the first, what do I have? I have the very first one, that is single population mean. So I would be just writing here single population mean. Okay, this one is my very first hypothesis test, that is single population mean. So okay, let me move a little bit above. Fine. Single population mean. So that is as well known as, I would just simply write single population mean, that is as well known as population. So I would just write here as population variance. Population variance. So if I just call that as single population mean or I call it as population variance, both are actually same. Okay, that is population variance, or you can just call that as a standard deviation or standard deviation. So I would just write that thing here as well, or standard deviation. Okay, so that is called as a normal test. So that is called as a normal test. I was just discussing about the types of hypothesis test, right? So in that case, if that is single population mean, which is known as population variance, or a standard deviation, so in that it is called as a normal test. Okay. Now moving towards the next, I have next category I have, which is single population mean, and that is basically single population mean, and that is the unknown population variance, unknown population variance, or you can just in the bracket I would just write SD, that is actually mean the standard deviation. So in that case, what will be applying? You will be applying out the students. Okay, you'll be applying out the students T test. Okay, this is the another one which will be applying out. So if you have single population mean and you have the unknown population variance, you need to find out the population variance. So in that case, you can apply out the students T test. This as well we have seen in the previous videos, right? Now moving towards the third one I have here, that is single population proportion. Okay, let me write the spelling here as correct. That is single. So that is actually single population proportion. Okay, so for the single population proportion, which test we actually apply here? So we just apply here the normal test only. So that is normal test, right? Here we had put on the three conditions. Let me take out the scroller, then I would just show you just 1 second right here. So what are the types of hypothesis tests? So when we have single population mean and we have the known population variance or standard deviation, then that is a normal test. When we have single population mean and the unknown population variance or standard deviation, that is the student's T test. And when we have single population proportion, so in that case, that is the normal test, right? Let me just go above and give you an overview of all the formulas which we have discussed right now. So we have discussed about the H0 and the HA, right? We had seen about H0 and HA. So value we just denote H0 as the null hypothesis and HA as the alternate hypothesis. Then we had checked out that if H0 has, these were some conditions which are put on for the H0. So if H0 is equal, so in that case my alternate hypothesis, that is HA, would be not equal or greater than or less than. In next, if H0 is basically greater than or equal to, so in that case my HA, that is my alternate hypothesis, that would be less than. And if H0 is less than or equal to, so in that case my HA would be greater than. Fine. Now if basically we have a condition that if alpha is less than equal to p value, then in that case we just do not reject out the H0, that is the null hypothesis. Fine. And if alpha is actually greater than p value, okay, if alpha is greater than p value, so in that case you can just reject out the H0. After that, alpha is a preconceived means that its value is set before the hypothesis test. Okay, so in that case the p value is calculated from the data. Then basically we had seen about the type 1 and the type 2 errors. So what about my type 1 error? So in that case, my type 1 error is my probability of rejecting out a null hypothesis when the null hypothesis is true, right? And what about the type 2 error? Okay, just one more thing regarding a type 1, that type 1 is denoted through alpha, right? Now type 2 error is denoted by the beta, and in that case the probability of rejecting the null hypothesis when the null hypothesis is false, right? After that, we have a very important condition to look upon here, that if there is no given preconceived value for alpha, then you can automatically use a value for alpha as 0.05. Okay, this is the thing that you should make sure of. After that, we had discussed about different hypotheses there. So the test in which single population mean and the known population variance, that is called our normal test. Okay, that is the normal test. Then the second which we have discussed was single population mean and unknown population variance or standard deviation. So that was student state test, right? That was the student state test. And the third one was a single population proportion. So that one is as well my normal test, right? So these are the things which we have all actually discussed out here. So as to, okay, just give me 1 second. Let me open the same section which we were writing. Just give me 1 second right here. Okay, 1 minute. Fine. So this was the one which we were actually discussing about, right? So this was about a discussion of all of these things which we have actually seen out here, right? So let me just open out that section once again. Let me just write out that thing. Yes, so this was a summary of the formulas, right, that we are actually written and seen out here. So here we have just completed out all the summary for the hypothesis test topic, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today I'll be discussing about a new topic in this statistics, and that is comparing two independent population means with unknown population standard deviation. Right, this is a new topic which we are going to start today. Fine. So I'll be discussing about this topic in detail. Fine. So just let me quickly take out one color from here so that we can start writing as well about the topic which we are discussing, and that is actually okay. Right here. Now, what I just meant from comparing two independent population means with the unknown population standard deviation, in that I would just take two independent population means and I would just compare that with the unknown population standard deviation. This is what I just meant from this particular topic. Right, now in this, first of all, let me just put out some points here that will actually help us to go through this topic a little bit more in detail. Right, let me just come down here and get out some space for writing. Let's get started. So my very first point starts that the two independent samples. So as we are just talking about the independent terms here, so we'll be taking that throughout the video, right? So the two independent samples are simple random samples from two distinct population. So what do I first of all meant from the term that is two independent samples? First of all, we need to discuss that particular thing, right, that we are just discussing about in a particular term. So what do we just first of all meant from it? So the two independent samples are simple random samples from two distinct population, right? This is the thing about the two independent samples. Fine. After that we have both populations are normally okay, let me come down. Fine, yes, so both populations are normally distributed. Let me just write here as distributed. Both populations are normally distributed with the population means and the standard deviations and standard deviations, right? So the populations are normally distributed with the population means and the standard deviations unknown, KNO, and here I just write unknown unless the sample unless the sample size are greater than 30. In that case, in that case, I would just write the population here only, okay? In that case, the population need not be normally distributed. I would just write here as distributed. So here goes this. Right, now just first of all, let's read out the definition with a proper thing, that both populations are normally distributed with the population means and standard deviations unknown unless the sample size are greater than 30. In that case, the population need not to be normally distributed. Now, both the populations which are normal distribution which we are talking about with the population means and the standard deviation are unknown till the point the sample size are greater than 30. If the sample size is not greater than 30, so in that case the population need not be normally distributed. Hope you just got this thing very much clearly, what I am just trying to tell you right here. Fine. Now, basically, okay, let me just come down and write out a note for you here, so that would be actually beneficial for putting out the things. So I would just write out a note for you. Fine. So my note, okay, I will just write here the test comparing to independent, the test comparing to independent population means, okay. So the test comparing to independent population means with unknown, I would just write here with unknown and possibly unequal population standard deviation, unequal population standard deviation, unequal population standard deviation is called the, we introduce a new term to you, is called the, I would just first of all write that, so that is Aspin, ASPIN, Aspin-Welch, that is WELCH, Aspin-Welch test. The degrees, I would just tell you one more interesting fact about this. So the degrees of the spelling for degrees is right. The degrees of freedom. We had discussed about degrees of freedom in the previous videos, right? So degrees of freedom of formula. Okay, let me write out formula. Okay, so the degrees of freedom formula was developed by Aspin-Welch, WELCH, right? Now, this is very important thing that you should pay attention towards, that basically, first of all, this is one of the note that we are going to discuss. So the test comparing two independent population means with unknown and possibly unequal population standard deviation is called the Aspin-Welch test. Make sure to remember this term very carefully. I will repeat it once again. The test comparing two independent population means with unknown and possibly unequal population standard deviation is called the Aspin-Welch test, and the term that was degrees of freedom, this formula was actually developed by Aspin-Welch test. Sorry, Aspin-Welch. Okay, this was actually made by Aspin-Welch. Fine. Okay, now let me calm down. Fine. Now basically here we have some formula as well of the standard error. Okay. Now basically we have some standard error here, and that we'll be discussing about. What I would just do here is that, let's say we take our difference of x1 bar minus x2 bar. Okay. And now okay, let me just write out that particular thing as well here. So I would just write about that. The first of all, difference in the sample means. Okay, so I would just write here difference in sample, difference in sample mean. Okay, so what will be the difference in the sample mean? That is quite okay. So x1 bar and minus x2 bar. So x1 is one of my sample and x2 is one of my sample. Sorry, mean x1 is one of my sample mean and x2 is one another of my sample mean, and we'll be just subtracting them both. So in that case, what I'll be getting? I'll be getting out the difference of both of the sample means, right? That is okay. Now, if I just want to find out the standard error, so I could just write here the standard. I could just write here the standard error is. I could just write here that the standard error is, and I could just put on the root and write out the formula here. So the formula which I'm just going to discuss today is S1 is square upon N1 plus next I have S2 is square upon N2, right? So this is basically what the formula I'm just going to discuss, that is for the standard error, that is S1 is square upon N1 plus S2 is square upon N2. So this is the formula for the standard error which we are actually having here, right? And the difference in the sample mean, that is absolutely okay, that we all know that it is basically the x1 bar minus x2 bar. So we were discussing about comparing the two independent population means with the unknown population standard deviation. So in that case, the first one thing was about the independent sample, that the two independent sample are simple random samples from two distinct population. This was a term, right? Other than that, second was that both populations are normally distributed with the population means and the standard deviations unknown unless the sample size are greater than 30. In that case, the population need not be normally distributed. So if the sample size which you are having, that is less than 30, so in that case the population need not be normally distributed. Then we discussed about Aspin-Welch test. So the test comparing two independent population means with unknown and possibly unequal population standard deviation is called the Aspin-Welch test. So this is one new term that we introduced today, and one new thing I just told you right here, that the degrees of freedom formula, the formula which was of the degrees of freedom that we had already seen in the previous video, so that was developed even by Aspin-Welch. Then we saw that what is the difference in the sample mean, so that is quite okay, that is like quite familiar with you all, and that is x1 bar minus x2 bar. And what about the standard errors? The standard errors is under root s1 square upon n plus s2 square upon n. Okay, just one more thing to mention here. Yeah, it is n1 and n2, this is absolutely right. So the s1 square upon n1 plus s2 square upon n2 and the whole under root. Right, so this was even the formula that we have discussed, right? So hope you just got the idea regarding the comparison of two independent population means with unknown population standard deviation. Right, so this was about this particular topic, and we'll be continuing this thing in the next video, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So in the previous statistics video, we had seen about the topic which was comparing two independent population means with the unknown population standard deviation, right? This was the topic which we had seen in the previous video. Now today we'll be continuing out this topic, but before doing that, just let me give you an overview so that you can correlate from the previous video whatever we had studied out, right? So the two independent samples are some simple random samples from two distinct populations, right? That we had understood, right? We had understood even that if the both populations are normally distributed with the population means and standard deviations unknown unless the sample size are greater than 30. In that case, the population need not be normally distributed. Right, we had seen out these things. Now, we had even seen one very much important thing here. That was a note. So, my note was the test comparing two independent population means with unknown and possibly unequal population standard deviation is called the Aspin-Welch test. So, we had seen this new test name which was Aspin-Welch test, right? And even we had seen that the degrees of freedom formula was developed by Aspin-Welch. Then we had seen about the difference in the sample mean, that is x1 bar minus x2 bar, and even we had seen about the standard error. This was all that we had seen in the previous video. Now today we will be doing out the t-score. Now we will be seeing out the t-score for this particular. So let me just take out some color so that we can differentiate between the two. Okay, right here let's start. So I would just start writing that the test is statistics. The test is statistic. That is basically what? That is the t-score. Fine. So test statistic data t-score is basically calculated as follows. Okay, it is basically calculated as follows. Now let's put out the formula for calculating out this t-score. Okay, let's put out that particular formula. So here I am having the formula, which is x1 bar minus x2 bar. This is the same mean which we had calculated above. Okay, x1 bar minus x2 bar. Subtraction with the mu1 minus mu2. Okay, mu1 minus mu2. Just hold on for a while. I'll be letting you know that what are these x1, x2, what are this mu1, mu2. Everything I'll be telling you out, right? Then onto the denominator, put out the under root and use here s1 upon n1. Okay, s1 upon n1, that is the whole square. Not the whole square, just 1 second. Here it is only s1 square. Okay, don't make this mistake next time. And here we have s2 and here goes the whole square upon n2. This is the formula for calculating out the the test statistic, that is basically the t-score. Now it seems to be a little bit of harder formula, but if you just come on and see out this formula, so it's not that much harder. See here, what is x1 minus x2 bar? That is okay. We subtracted from the mu1 minus mu2 and onto the under root what we put out. Just let me go above. Onto the under root, we just put out the standard error which we had already calculated. This was the formula, right? And now just match out the formula which I had put on the denominator. Yes, the formula is absolutely same. There is nothing new which we are actually doing. We are simply using one new thing, which is mu1 minus mu2. Right? Fine. Now what I would tell that what x1, x2, s1, s1 and all these things are actually right here. Fine. So let's start here. So I would write s1 and s2. Okay, s1 and s2. These are the samples. The sample standard deviations are estimated of sigma 1 and sigma 2. Okay, so S1 and S2 basically are the sample standard deviation and basically are estimated of sigma 1 and sigma 2. Fine, this is the idea. After this, I'll be putting out the sigma 1 and sigma 2, that what are these two things which we are having. So sigma 1 and sigma 2, these are basically the unknown. These are the unknown population standard deviation. These are the unknown population standard deviation, right? Okay, so I would just put out. Now just please see out the differences between both of these, because the difference here are okay. So I had just S1 and S2 are the sample standard deviation which are estimated of sigma 1 and sigma 2. And what is the sigma 1 and sigma 2? So these are the unknown population standard deviation, right? And after that, what we are having? We are having x1 bar and x2 bar. So what are these x1 and x2 bars? So these are the sample. These are the sample mean. These are the sample. Where's my pen? Okay, these are the sample mean. Okay, and mu1 and mu2, and I would just put out here. Let that be mu1 and mu2. Let me now just come down a little bit. So here are down. So mu1 and mu2, these are basically, so I would just put on here, these are the population mean. So population mean. Now understand it in here that what are this S1 and S2. So S1 and S2 are basically the sample standard deviation are estimated of sigma 1 and sigma 2. So these are actually estimated of sigma 1 and sigma 2. Now what is the sigma 1 and sigma 2? So these are the unknown population standard deviations, right? Now let's see about x1 bar and x2 bar. So x1 bar and x2 bar are the sample means which we are having out here. What about the mu1 and mu2? So mu1 and mu2 are the population mean, right? So all the 4 parameters which we have listed above into the formula, we had just got out the idea that what are these formulas, right? I mean parameters, right? Now let's see about the degrees of freedom. The degrees, I would just now take the topic which is degrees of freedom. Okay, so I would just write here the degrees of freedom, that is we basically call it as DF. I would just write here as DF. Okay, so degrees of freedom DF is basically is a complicated calculation. It's it's a little bit of complicated calculation. The formula is not complicated, but yeah, calculating out this degrees of freedom is a complicated calculation, right? Now, fine. So basically, basically DFs are not always a whole number. Okay, we are going to divide out some things here. So we can say that the DF which we will be calculating, the DFs which we are calculating, that are not always the whole numbers. Okay, the test statistics calculated, that is the T-score. The T-score which is calculated above is basically approximated by the student seat distribution with DFs as follows. Okay, I will just let you know that. Let me write out that thing. Fine. Okay, one more thing, that if you're just going to calculate out the degrees of freedom with the help of a calculator, it can easily be calculated actually. Okay, but if you're just going to do out manually, yeah, you can make out some mistakes at some point. Okay, let me write that. So I would just write that the DFs are not always a whole number. The DFs are not always a whole number. Okay, so DFs are not always the whole number. Let me come down here. Okay, here goes the test. The test statistic, that is basically I'm referring to the T-score. Let me write that T-score in the bracket only. Fine. Okay, the test statistic, that is the T-score, calculated, the above one which we have calculated. Okay, the calculated above is approximated by the students T distribution. I would just write students T distribution. So basically the T-score which is calculated, which we have calculated actually above, so that is approximated by the student T distribution with DFs. That is my degrees of freedom, right? So basically now let's write out the formula for this DF which we are actually having out here. So degrees of freedom, the formula for the same is, I would just put on here as DF is equal to okay, inside the large bracket I have S1 upon N1. Okay, this S1 basically will be squared out. So okay, just one second, let me write it in a fair handwriting because it's a little bit complicated one. So okay, so S1 upon N1. Okay, and this S1 would be actually squared. S1 upon N1. After that we have the same which is S2. This S2 will as well be squared, and upon we are having N2. Okay, now this is in the numerator, the whole square of this actually. Fine. This is the thing which we are actually having here in the numerator. Now let's go to the denominator, and let me just come down here. Fine. Into the denominator we are having 1 upon, here goes the N1 minus 1. Okay, multiplied by bracket, and into the bracket I am having S1 upon N1, and this S1 would actually be squared. So like this, S1 square upon N1. Close out this bracket and put out the square for this. Right, now plus 1 upon N2 minus 1. And here I am again having the same, which is actually now not the S1, it is S2 square upon N2, the bracket like this, and here goes the square of it. Fine. This is the whole formula for calculating out the degrees of freedom, and here goes the multiplication. So formula for calculating out the degrees of freedom, this is the formula which we are having for calculating out the degrees of freedom. Now let me come down and put out the things here. Fine, let me just tell you that what are the things which mean. So I would just write here something as well. So when both sample size which we are having, when the both sample size N1 and N2, okay, both the sample sizes which we are having N1 and N2, okay, are 5 or larger. Okay, when the both sample size are 5 or basically larger than 5, then in that case, then the students T I will just write that approximation is very good. We can say that is very good actually. I would just write here very good. So when both the sample size N1 and N2 are 5 or larger than 5, then basically the student's T approximation is said to be very good. Okay. Now, basically, yeah, after this we do not have any particular specifications for this particular thing, right? Let me just go above and let you know that what we had done today. So we had seen that how we can just calculate out the t-score. So we had seen out the formula that was x1 bar minus x2 bar minus mu1 minus mu2 upon we had under root s1 square upon n1 plus s2 square upon n2. After that, we had seen S1 and S2 were a sample standard deviation which are estimated of sigma 1 and sigma 2. And sigma 1 and sigma 2 are the unknown population standard deviations, right? X1 bar and X2 bar are the sample mean. Mu1 and mu2 are the population mean. The degrees of freedom, that is DF, is a very complicated calculation. So DFs are not always a whole number. The test statistic t-score calculated above is approximated by the student's T distributed with DFs, right? So this was the formula which we had seen. DF is equal to S1 square upon N1 plus S2 square upon N2 whole square divided by 1 upon N1 minus 1 multiplied by S1 square upon N1 whole square plus 1 upon N2 minus 1 multiplied by S2 square upon N2 whole square. When both the sample size N1 and N2 are 5 or larger, then the student's T approximation is said to be very good. Right. Hope you just got the idea regarding the formulas for the t-score and the degrees of freedom. Right. So this is all for this video. Till then, thank you and take care. Hello everyone. My name is Shambhavi. Hope you all are doing well. So today we are going to solve out the question in the statistics basically. So we are going to solve out the question for this independent groups, right? So we'll be seeing and going throughout this question. What are the formulas I will be using? We have already discussed all of those things into the previous video, right? So I would just not repeat that once again here. I would directly put on the formulas onto the particular questions and get out the answers for that. Right, so let's get started here. Before that, just let me quickly choose out a color so that we can proceed on with the stuff and doing of all the stuffs, okay? Right here. So this is my question, that is, the average amount of time boys and girls ages 7 through 11 spend playing sports each day is believed to be the same. An experiment is done, data is collected, resulting in the table below. Both populations have a normal distribution. So this is basically the whole idea. We are having here the sample size for the girls. For the boys, we are having the average number of hours playing sports per day and the sample standard deviation for both of them. All of these things we are actually having out here, right? Now, okay, what's my question that I need to find out the answer for? So my question that I need to find the answer for is there a difference in the mean amount of time boys and girls ages 7 through 11 play sports each day, just at the 5% level of significance, right? So we are, first of all, we need to find out the difference, that is there any, and after that we need to test it at the 5% level of significance, right? So let's get started and solve out this particular question. So I would just write here solution. Let's write out here and start up. Fine. We are already knowing the population standard deviation. So I would just write that the population. I would just put on that particular thing because that is thing which we already know. So I would just write the population standard. The population is standard, and I would just put on here as deviation. The population standard deviation is okay, so population standard deviation is not known to us. Only sample standard deviation is known. The population standard deviation is not known. Okay, the sample standard deviation we know, but the population standard deviation we do not know. And yeah, these both are the different things, right? We are already understood and discussed about a lot of all these things in the previous video. Fine. Okay, now let's take a page variable. Let's take a variable that is G. Okay, so I would just write that let G be the subscript for girls and B the subscript for boys. Okay, I'm just taking two different variables for the girls and even for the boys, and we will the subscript for, and I would just write here for boys. Okay, I'm just taking both of the respective things, right, that I had just put on here. After that, I would just put on then. Okay, then I will put out a comma and I would just write here then mu g. Okay, then mu g is the population mean. It is the population mean for girls, girls, and mu b, I would just write here mu b is the population mean for the boys. That's the population mean for let me come down for, and I would just put on here as boys. Okay, right. So these are the things which we are listed above. So population standard deviation is not known. So in that case, let G be the subscript for the girls and B be the subscript for the boys. Then mu G is the population mean for girls and mu B is the population mean for boys. Okay. After this, I would just put on here that this is a set of two independent, I would just write independent. Okay, this is a set of two independent groups. Okay, the set of two independent groups, and comma, we have even two population means. So I will just write two population and put on here as means. Okay, right, that all the things are actually done out here. What I would just come down, I would just come out and go the things for the random variable. I just put out here as random, and here we have variable. Fine. So what we are gonna do here is that we will be writing out that what's the difference between the sample mean in the amount of girls and the amount of boys. I would just do that. So I would simply write x bar g minus x bar of b. Okay, this is basically what this is the difference in the sample mean amount of time girls and boys play sports each day. Play sports each day. Okay, so this is the idea random variable xg like x bar g minus x bar b. That is the difference in the sample mean amount of time girls and boys play sports each day. Okay, that is absolutely fine. Now what I would just do here is that I would be coming down once again and right. Now let's give it some denotions and let's put out some values here. Okay, so in that case I'll be writing here h naught. Okay, h naught is basically what is that? That is mu g, and that will be equal to mu b. That is my mean for the girls and mean for the boys. And what I would just do, I would just write mean for girls minus mean for boys, that is equal to 0. Fine. Right here, now what I would just even do, I would just put one more condition. Let's say that is HA, and that would be mu of G is not equal to mu of B. First was my condition that they both are equal, and second is my that they both are not equal. So mu G minus mu B will not be equal to 0. Find my two conditions that I have applied out. Okay. Now, let me just write out here. Fine. So I would just now put on the things. Right. So the words that are written, which is the same. The words that are written that is the same tell you h naught has an this equal to sign. Okay, the words the same tell you h naught has an equal, right? So since there are no other words, since there are no other words to I would just put on here indicate, since there are no other words to indicate HA. Okay, that is my HA. Then in that case, then assume that it is different. Fine. Okay, see, the words the same tell you it's not has an equal to sign, right? Then there are no other words to indicate HA. Then assume that basically it is different, right? So here what we are doing here, we are taking a two-tailed test. Okay, I would just write that here. It is a two-tailed test which we are actually trying to do out here, right? Now, let's do out a distribution for this particular thing. So let me just come down here, and I would just write distribution for the test. I would just write here distribution for the test. Put out a full stop, and I would just write here use T of DF. Let me remove this out. Use, and I would just write here use T of, and I will just put on here as DF. Okay, use T of DF where I will just put on where DF is calculated, using the DF formula which we already have for the degrees of freedom. Yes, right, remember we have already seen that yesterday. Formula for independent groups. Okay, for independent groups. Okay, now you are already known with the formula that what's the formula for calculating out this degrees of freedom. So I would just not let you know whole procedure, whole things in hand. Okay, you already know the formula, you already know that what are the symbols that belong to what. So basically put out that formula. Fine. So I would just simply write the final answer for DF. So that is approximately equal to 18.8. Just find that on your own. Okay, I'm just not gonna put out the things again and again totally for you. Okay. Okay. So, and even what you could do, you can just find out the p-value as well. P-value, and how will that be found? So p-value can be found. P-value can be found using students T distribution. Using students T distribution. And if it is not getting that how to put out the formula and all those things, so you can just ask all the things to me in the chat box, right? So p-value can be found using students T distribution, and that would be approximately equal to that. You also need to find out on your own. So the value for that would be approximately equal to 0.005 or something like that. Okay, fine. Just put out that find out all of those things. Now what we can just do out here is that we can actually make out a graph for this particular thing. Let's see how to make out the graph. Let me put out this, and let me just put out this particular thing like this right here, and fine. After this I would just put out and make out the graph for this thing. Okay, 1 second. So it is a little bit of graph like this, and here we go. Fine, absolutely okay. And here I'll just put out the things like this. After this, I have here two portions which are actually colored out, and I would just write the things onto that. Now, what are these actually? These are my p-values, the half of this p-value and half. So I would just write out here half of p-value. So what was my p-value which was founded above? So that was around 0.055 it was around 4. Okay, it was around this time. So when I just 1/2 here, so it would be around for me 0.00, and it would be 28. Again here as well, this is the half of my p-value, so that would again be 0.028, same value. Okay, let me now just come down here and plot the other things for this particular. Okay, just 1 second. Yes, now here what do I have? I have the values in middle, it is 0, here it is minus 1.2, and here it's basically plus 1.2. After this, what else we have here to put on? Okay, we have here x of g bar minus x of b bar like this. Okay, we have this as well. Okay, fine. So these are the things which we are actually having right here. So and this portion is actually shaded, so I would just put out the some things like this, right? Fine, this is the graph which would actually come. Now, what are the things that we can just conclude from here? So we were already given SG, right? We were already given this particular thing, and let me just go above and show you where we are getting. right? So we are already given this value, which is under root of 0.75, right? Under root of 0.75. So I would just write SG is equal to under root of 0.75. So what is the SB? SB is as well given as when, that we had already seen. So we could just write that x bar G minus x bar B. So that is equal to 2 minus 3.2, and that would be actually equal to minus 1.2. So basically, what is this minus 1.2? Hope you have just seen out the graph. I just plotted out two things, minus 1.2 and plus 1.2 right here. So basically, it is the same thing only. So I would just write here half the p value is basically below 1.2, below minus 1.2, and basically half is above 1.2. Okay, now since basically we can just now make out a decision here. So I would just write out or make a decision. We can finally make out a decision here that since alpha is greater than p value, that we had already figured out here, right? That alpha is actually greater than p value. What is my alpha? Alpha is my 1.2, which I have actually got out here. So this is greater than p value. So what we'll be doing, we'll be rejecting the h naught. This means, so the statement which I have written above, this means you reject mu g, which is equal to mu b. The means are different. I would just write here that now the means are different. Right? So hope you just got out this question, that how I have proceeded on with this question. Now this question is even having the second part, which I just need to find out, test at the 5% level of significance. So I would just give you some time to figure out this particular question on your own, and we'll be discussing at the answer of this particular question in the next video, right? So hope you just got the idea that how you would be able to solve out the questions like this. Now this 2 and this 3.2, hope you just remember the idea that here the 2 and 3.2 which I had used out, this xg minus xb, it is from that particular table only which I am having here, right? This 2 and this 3.2, right? Hello everyone, my name is Shambhavi. Hope you all are doing well. So into the previous video, we had watched out a question for the topics which we have discussed, right? So now basically in today's video, we are going to see two topics in this particular video. First, let me remove this lining which I had actually made out. And let me take out the colors from here so that we can start writing as well. Okay, fine. So what we are going to discuss, first of all, we are going to discuss regarding the comparison of two independent population means with known population standard deviation. Now this is a case when the two independent population means are there, we need to compare them. But what is my condition that applies? My condition applies that it should have known population standard deviation. This is my condition which is actually applying out here, right? So we are going to discuss this particular thing today. And as soon as we proceed on, I will let you know the second topic as well, which we are going to discuss right here. Okay, so let's get started. Okay, so let me put on the topic here. So my topic for today's discussion is comparison. Okay, that is not comparison, that is comparing. Okay, it's comparing two independent population means with it's like this, with known population standard deviations. Okay, so this is the topic for discussion of today. Right, so in this basically we are going to see out one of the formulas that is actually right here, which we'll be discussing out. Okay, there is nothing too much regarding the formula here into this particular topic actually. Okay, so let me just take out a color here, that are some different colors, so that we can proceed on with writing, and let's go. So Okay, okay, now just let me let you know something. The sampling distribution for the difference between the means is normal and both the population must be normal. It is the condition which applies that the sampling distribution for the difference between the means is normal, okay, and the population must be normal. Both the populations which are there, that must be normal actually, right? Now, after that, basically, we are having a random variable, right? That was x1 bar minus x2 bar, which we had already seen into the previous video. Remember that we had already seen out some of the formulas, and there it was mentioned regarding some x1 bar minus x2 bar, right? So that normal distribution basically has a format. So that format we are gonna see here. So I would just write here normal. Okay, not like this. So here goes the normal and comes the distribution, normal distribution. Okay, so it's like this, normal distribution. Now what's the formula which is basically into this? So the formula is x1 bar minus x2 bar, which I just told you. That what is that? That is a random variable. Okay, which is approximately equal to capital N. Okay, then here goes the mu1 minus. Okay, so basically now here we are having u1, not mu1. Just 1 second, that is right here. Minus u2, comma, then we have under root of sigma 1 square upon n1 plus sigma 2 square upon n2, right? So these are some things which we are actually having right here. Okay, now into this particular, what is the standard deviation? This was a normal distribution, right? Into this, I would just write the standard deviation is. Now we'll be discussing about the standard deviation. That what is the standard deviation, which is right here. So that is around under root of sigma 1 square upon n1 plus sigma 2 square upon n2. Okay, so this is the standard deviation which we actually have here, right? So that is under root of sigma 1 square by n1 and plus sigma 2 square by n2. This is the standard deviation. Okay, after that we have the test. The test statistic. The test statistic into the bracket, that's actually the z-score. So the z-score, right? Now this as well we are having. So into this, okay. Now what I would just do, I would just write z is equal to the formula for this particular one is basically x1 bar minus x2 bar. Putting out the bracket minus, then we have mu1 minus mu2, right? And all of the things would be actually divided by under root of sigma 1 upon n1, the sigma 1 square upon n1 plus then we have sigma 2 square upon n2, right? Fine. So these are the sigma 1 and the sigma 2 values which we will be having into this particular z-score formula. So test statistic that we actually call as z-score as well, right? We have discussed this thing already into the previous video, right? So that I'm just writing out here the formula, that is x1 bar minus x2 bar. That would be in bracket subtracted by bracket mu1 minus mu2 under root of divided by under root of sigma 1 square by n1 plus sigma 2 square by n2, right? This is out. So there is nothing too much into this particular topic, that is comparing two independent population means with unknown population standard deviation. Okay, these only were the formulas which I wanted to let you know. Now after this, as I mentioned, that we'll be discussing the second topic as well into this particular video only. So now let's discuss out that second topic that I was about to discuss. So that name of the particular topic is comparing two independent. So here goes the independent population proportions. Okay, this is basically the next one which we are going to discuss today. That is basically the comparing two independent population proportions, right? Okay, now okay, let me just write out some things here first of all. Why these slash are coming? Let me come down. Fine. Let me write out the first point here. Let's say that is here. Fine. So I would just write that the two independent samples, the two independent samples, so samples, the two independent samples are simple random samples are simple random samples that are independent. So that are independent. So what do we mean by two independent samples? So two independent samples means that these are the random samples that are actually independent. Okay. Second point regarding this is the number of successes. The number of successes is at least 5 and the number of successes is at least 5 and the number of failure is at least 5 for each of the samples. Now this is one another thing that comes, that number of successes is at least 5 and even the number of failure is as well like at least 5 for each of the samples. Fine. Now next thing regarding this. Now next thing I would just write here comparing two proportions. Comparing two proportions like comparing two means, is common. Basically whenever we just say about comparing of the two proportions, like let's say I just take an example that I would compare two means. So yeah, that is a very common thing that actually occurs, right? If basically two estimated proportions are different, then it can be like this particular thing can be because of the difference in the population, or it can be due to the chance, right? The two conditions can be actually applied if if two estimated proportions are different. First one, it can be due to the difference in the population, and the second one, that it basically can be due to the chance. Right. So now basically a hypothesis test is the one which helps in determining the estimated proportion. Let me write out this important thing, that the hypothesis test can help determine, the hypothesis test can help determine proportions, determine it help determine if basically if a difference in the estimated proportions. Here goes the proportions. Okay. Yes, the hypothesis test can be determined if a difference in the estimated proportions PA, that is noted PA minus PB. Okay, so PA minus PB reflects a difference in the population proportion. Right, so the hypothesis test can actually help you to determine a difference in the estimated proportions PA minus PB, which reflects a difference in the population proportion. Right. Now, this difference basically, or this difference of the two proportions actually follow out an approximate normal distribution. Okay. Now, generally, what does the null hypothesis test tells us? So null hypothesis basically states that the two proportions are the same, right? It basically tells us that the two proportions are the same, right? That is basically H naught. Okay, it is basically, we just wrote it like this, right? The H naught, or you could just H0 as well. So that is PA is equal to PB. We used to write it like this, right? And P was a small after, not capital. Right? We used to write out the null hypothesis like this because we had already discussed this thing in the previous videos. So basically, to conduct out this test, we basically use out a proportion, that is P. Right? Hope you just got the idea regarding this thing. So that is PC. Actually, to conduct out this, we just actually, in the terms of like this thing, we just call it as pooled proportion. POOLED, pooled proportion. Okay. So this pooled proportion is basically calculated by the P, like the denotation which we give it is actually PC. Capital P and then sorry, small p, and then in the denominator it's C. So it's like okay, let me remove out this thing. It's P and here it's C. Okay, this P is actually small, so it's small p and here goes the C. Right, this is actually how we just like denote out this pool proportion. So hope you just got out the idea regarding this particular thing. Now there are several formulas as well into this, but we are not just going to discuss this right here. We'll be discussing into the next video. So we saw that comparison between the two independent population means with the known population standard deviations, and even we see the comparison of two independent population proportions. Right. Hope you just got the idea regarding all of these things which I told you regarding the formulas and regarding some theoretical things which I just mentioned. Right. So this is all for this video. Till then, thank you and take care. Hello everyone. My name is Shambhavi. Hope you all are doing well. So in the previous video, we had seen one topic. Just let me first of all open out that particular place, and yeah, here it was. So we had seen regarding the comparison or comparing of the two independent population means with the known population standard deviations, right? This was what we had discussed today with the topic as well. We had seen the comparing of two independent population proportion, but yeah, that is right now we are just not going to consider that particular topic. So in today's video, we are going to see out a question with this particular topic, right? Let me just write out here as question. Just 1 second. So let me just write out here as question, fine. So we are going to solve out this particular question in today's video, which is totally related to the to the formulas which we had already seen into that topic which I was discussing, and that is comparing two independent population means with the known population standard deviations. Right, so let's get started. So now what does my question says to me? So my question says independent groups, population standard deviations known. The mean lasting time of two competing floor waxes is to be compared. 20 floors are randomly assigned to test each wax. Both populations have a normal distribution. The following table is the result. What is the question that you need to find? The question is that does the data indicate that wax 1 is more effective than wax 2? Take at least test at a 5% level of significance, right? Okay, so this is a particular question which we need to solve out here. In this question, I am mentioned what are things that I am given. Let me take out a highlighter and highlight all that things. Right, yeah. So I'm just given the mean lasting time of two competing floor waxes to be compared. 20 floors are randomly assigned. So randomly assigned value is 20 floors, right? To test each wax. Both populations have a normal distribution. The following table is the result. This is the main table which we'll be seeing wax 1 and 2. Then we had sample mean, that is the number of months floor wax last. So for wax 1 it is 3 and for wax 2 it is 2.9. And the population standard deviation, so the population standard deviation for wax 1 is 0.33 and for the wax number 2 is 0.36. Right, so now we just need to find out the things here. So let me just take out a pen and let me just go on to the color and figure out a pen here, and then let's get started with the writing part. So okay, let's find out the solution for this particular question which we are given out. So we need to find out that does the data indicate that wax 1 is more effective than wax 2, and second one is test at a 5% level of significance. Fine. So let me come down here. Fine, let's start writing out the solution. So in my solution it says this is a test of two independent groups of independent groups, right? So this is a test of two independent groups, and okay, independent groups comma two population means, I would just write that two population means it is population standard deviation, its population is standard deviation, that ST is standard deviation, okay, okay, not that is S dot D standard deviation, okay, population standard deviation, fine. And yeah, so this is basically the things which we are already know, standard deviation no. Okay, so this is a test of two independent groups, two population means population standard deviation is known. Okay, what about the random variable? So random variable, that is x1 bar minus x2 bar is equal to difference in the mean number of months the competing floor, okay, let me remove out this competing because we are not able to understand that what I have written out here, even I am not able. So right, months mean the number of months the competing floor waxes last. Okay, so this is the idea that the random variable, that is x1 bar minus x2 bar, is equal to the difference in the mean number of months the competing floor waxes last. Okay, now what is this h naught? H, that is h0. What is this actually? So it is mu1 less than equal to mu2. Okay, what about HA, that is alternative hypothesis. Above one was null and down one is alternative hypothesis. So that one is mu1 greater than mu2, right? These are the conditions which we were having in this. Now come down. Write out the next thing, that the votes. Now if you have read out the question carefully, then you must be getting out this particular sentence. The vote is more effective. Says that wax 1 lasts longer than wax 2, right? When we just talk about that something is more effective, so in that case you are just like indirectly saying that this particular thing lasts longer than this particular thing, right? So here we have taken the example for the wax. So when this term came that which wax is more effective, so in that case it actually means that like wax 1 lasts longer than the wax 2. Okay, fine. On the average, we are not just completely satisfying because we need to find out this particular thing, but yeah, onto the average we can just put out this particular thing, that on the average, full stop. After that, longer is a greater symbol. Longer is a greater symbol and goes to HA. That is basically my alternate hypothesis. So it means that this is a right. Let me just come down. So it means that this is a right-tailed test. Okay, it means that it is a right-tailed test. Fine. Now, what about the distribution for this particular test which we are given? So here comes the distribution. Okay, so we already know about the population standard deviation. We already know this particular thing, right? So basically the distribution is normal. In the case when we are familiar with the population standard deviation, so we say that this particular distribution is normal, right? So let's put out the formula. That is x1 bar minus x2 bar. Let me come down. Approximately equal to n into the bracket. Okay, now just figure out what was the formula for that standard normal distribution. U1 minus U2, yeah, right? So here just given 0. Nothing, I'm just I'm having here, right? Putting out the under root. We were having sigma 1 squared upon n1. Go above to the question, find out what is the sigma 1. What is sigma 1? Sigma 1 is my population standard deviation. So 1 is 0.33 and second is 0.36. What about the n? So n we are having total which is 20 floors. So that same I would be taking out. Right, now just let me come down here, put on the things. So for the first one we were having 0.33. Right, square upon n1 we were having 20 plus, and then we were having 0.36, right, whole square divided again by 20. Fine. So since mu1 is less than equal to mu2, then mu1 minus mu2, then mu1, okay, just let me come down. Since mu1 is less than equal to mu2, then mu1 minus mu2 is less than equal to 0, and the mean for the normal distribution is 0. Okay, the mean for the normal distribution is 0. Now when we are just going to calculate out the p-value, so that p-value is finally gonna come as 0.1799. See the formula for comparing of, okay, for finding out the p-value. Let me come down. So yeah, this was okay. So just find out this accordingly. And even the formula for the p-values, we had already discussed that into the previous videos, right? So that you can just took out from there. After that, if we talk about making out the graph for this particular thing, so I could click on draw and take out the x and the y. No, I do not want x and y axis. I simply want one single line. So I could just make that line like this here, and okay, where's that color gone? So just one second, draw and then color here, and here I could just make a normal distribution curve, right? This is how that normal distribution curve is made, right? Here I could just put on some points, and in between it would be 0. This is 0.1, and it is x1 bar minus x2 bar. This particular, what is that? That is my p-value. P, okay, just let me remove out this p, and here goes the value. So what is that p-value which we had find it out? 0.1799, right? We had just put on this thing. So, and what we had concluded from H0, that is my from null hypothesis, mu1 minus mu2 is less than equal to 0, right? This we had concluded. And taking out a color from here and putting out and filling out this particular portion, right? Because this is the one which we had actually find it out, this particular portion. Right, so that I have completed out here. So from this, what I could actually conclude, let me now just come down. I could put out here that x1 bar minus x2 bar, that was we were having 3 minus 2.9, that is equal to 0.1. Just have a look, we were having these two values. This is the 3 and this is 2.9. Okay. So x1 bar minus x2 bar, that is 3 minus 2.9, that is equal to 0. Now we are going to compare out the values actually. Compare alpha and the p value. Okay. So alpha we are having 0.05, right? What about the p value? So p value I was having 0.1799. So in that case I could say that alpha is less than the p value, right? How to find out alpha? We had already discussed this thing. So now here we can actually make out a decision that since alpha is less than p value, so do not reject H0, right? This was only the condition which satisfied that if alpha is less than the p value, then in that case we do not reject out the H0. So that is same actually which is applying out here. What about the conclusion for the 5% level of significance? So we can say that at the 5% level of significance from the data, from sample data which we are given, so there is not any sufficient evidence to conclude that the mean time wax for 1 lasts longer than the mean time wax lasts for 2, for the second wax last. So we are here basically we do not have any sufficient evidence to conclude out this particular thing that the mean time wax 1 last is longer than the mean time wax 2 last. Right? Hope you just got the idea that how to solve out this particular question. That does this indicate that the wax 1 is more effective than wax 2? Test at a 5 level 5% level of significance. So when it is mentioned 5% level of significance, so in that same case, I had taken the value for alpha is equal to 0.05. So this is the value which just came from 5%. It is only the 5%. Okay, make sure to remember out that thing, right? Hope you just got out the idea that how to solve the questions like this. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So last in the previous video, we had seen a question that was regarding the comparing of the two independent population means with the known population standard deviation rate. Yes, so this was a particular question that we had seen in the previous video, that how we will be solving this out. So in today's video, we are going to discuss about the comparing two independent population proportions. This is one of the topics that we have already covered into the one of the previous videos, but yeah, some formulas were left into that particular case, and after that we'll be solving out the question as well for this particular topic, right? So this is the whole idea regarding today's video. So let's get started. Okay, what I would just do is that right here I'll be giving you a quick revision what we had discussed in the previous video, right, regarding this particular topic. So the two independent samples are simple random samples that are independent. The number of successes is at least 5 and the number of failures is as well at least 5 for each of the sample, right? This was a thing which we had discussed out. Other than that, comparing two proportions, like comparing two means, is common. Okay, whenever you're just comparing out the two proportions, so it's basically like comparing two means. That is absolutely common. Okay, and the hypothesis test that can help us to determine if a difference in the estimated proportions PA minus PB reflects a difference in the population, right? So it's not just PA is equal to PB, and we had even seen that PC. Now this PC was basically the pooled proportion, right? Let me write it here as the same thing, which is pooled proportion. Right, this was the pooled proportion, that was PC, which we had discussed out. So today we'll be seeing out some formulas, and after that we'll be proceeding on to the question. Right, so here I would just take out a color so that we can just proceed on with the writing of the things right here. So first I'm going to see out the formula for the pooled proportion, okay. So basically, how is the pooled proportion actually calculated? So in that case, the pooled proportion is actually calculated. Here goes this PC is equal to, we have XA plus XB. Okay, we have this XA plus XB upon, then we have NA plus NB. Fine, so this is the formula that how the pooled proportion is actually calculated. Okay, this is the particular formula for that. After seeing out the pooled proportion, we have basically the second topic, that is the distribution. So basically that is the distribution for the difference, right? Distribution for the difference. So let me just come down at this particular place and let's put on the formula for this distribution for the difference. So that would be P dash A. Okay, that would be P dash A minus P dash B, which is approximately equal to capital N into the bracket. First of all, we have 0 comma. Then we basically put on the under root. Inside this under root, we have first of all PC, that is my pooled proportion, multiplied by 1 minus PC, that PC is again my pooled proportion, multiplied by 1 upon NA plus 1 upon NB. Fine, so this is the whole formula which we have for the distribution for the difference, right? This is the formula which actually continues and goes on for this particular topic, right? Now, after this, basically what do I am having here? So let me just come down to a new place right here. Now we have the test statistics at the Z score. Okay, the test statistic, and into the bracket it comes about the Z score. Okay, now just let me put out the, okay, here comes the colon. Okay, let me just remove out this dot from here, by mistake it has been put out. Oh, okay, Now let's take out the same color and put my bracket like this. Okay. Now let's come down and put out the formula for the test statistic, that is the z score. So formula for that is z is equal to, above I have p dash a minus p dash b minus, then we have pa minus pb whole divided upon, and then we have whole under root pc, my pole proportion, multiplied by 1 minus pc multiplied by 1 upon na plus 1 upon nb. Fine. So this is basically the formula for the test statistics, that is basically the z score. Right. So I hope you first of all understood regarding the formulas, that what are the formulas which we have for these three things. First one was the pole proportion. Second one was basically the distribution for the difference, and third one was the test statistic, that is basically the z score. Right. Now what we'll be doing is that we will be solving out a question regarding this particular topic only. So here is my question that we'll be dealing with today. So let me take out a highlighter once here for highlighting out the things. Right. So my question says two types of medication for hives are being tested to determine if there is a difference in the proportions of adult patient reactions. 20 out of a random sample of 200 adults given medication still had hives 30 minutes after taking the medication. 12 out of another random sample of 200 adults given medication B still had hives 30 minutes after taking the medication. Test at a 1% level of significance. So basically here we want to we have to test at a 1% level of significance, right? Okay. Now even it was written that this is a test of two population proportions. So my question was that how I would figure out that this is a test of two population proportions. Okay, so let's take out a color here and let's proceed on with the writing of the solution. Okay, now what I would just do, I would just write let A and B be the subscripts for medication. Okay, for medication A and medication B. Right, let A and B be the subscript for the medication A and medication B. Then what are the PA and PB? So then PA, this PA, one second, yes, then PA and PB are then PA and PB are the desired population proportions, desired population proportions. Okay, so let A and B be the subscript for the medication A and medication B, then PA and PB are the desired population proportions, right? Now, right here, after that I could just write out some things for the, like let's take out a random variable here. So that random variable would be P dash A minus P dash B. Okay, that is basically the difference in the proportion of adult patients who did not react after 30 minutes to the medication A and the medication B. Okay, just again listen to me because I'm just not going to write this out. That P dash A minus P dash B is basically equal to the difference in the proportion of adult patients who did not react after 30 minutes to medication A and medication B, right? So I'll be putting out the conditions here for the null hypothesis and for the alternate hypothesis. So for the null hypothesis, that is H0, we have PA is equal to PB, and in that case PA minus PB is equal to 0, right? And if I go for the alternate hypothesis, so in that case basically we have PA not equal to PB. So in that case as well, PA minus PB not equal to 0. Right, these are the things which I have here. Now, basically, the word basically is a difference that tells you that the test is a two-tailed test that we had as well seen in the previous video about this thing in a detail, right? Okay. After that, basically, now, what is the distribution for the test that we would be making out here? Okay. So the distribution will be that this is basically this is a two binomial population proportion test. So the distribution will be normal only. These are the things which we had already discussed in detail. That basically if a test is a two binomial population proportion, so in that case the distribution would be normal, right? So that same is actually written out here. After that, what I will be calculating out the pooled proportion, that is PC, which is equal to, that was XA plus XB upon NA plus NB, right? This was the formula which we had right now, or like actually seen out. So in that case it was 20 plus 12 divided by 200 plus 200. Now, how did I got this XA, XB and all the things? So just read out, if you have read out the question, you must have got this thing. That basically it was saying that for the patient proportion, let's see, 20 out of this 20 is basically my XA, okay? 20 out of random samples of 200 adults were given medication, and 12 out of other random samples. So from here this 20 and this 12, okay? And what was my sample for the 20 out of random? That was actually 200 only. And for the 12 out of another random sample, my again sample was 200. So with this way, I just got the values for XA, XB, NA plus NB, right? So when you're just going to calculate this out, you'll be getting 0.08 as the answer. Okay. And when we just calculate 1 minus PC, so 1 minus PC basically that is 0.92, right? Okay, so when you're just going to calculate, okay, let me write it in another way. So let me write it 0.08. I'll be writing 1 minus PC is equal to 0.08. So PC is equal to 0.9, 0.92, right? This is the correct way which we can just go ahead with, right? Now, in that case, if I had just found out this thing, so I would just write here. Therefore, what about the P dash A minus P dash B? Okay, not from here. Let me just, therefore, let me write it from here. So P dash A minus P dash B. What was the formula which we had right now as well seen? So bracket 0, comma. Then we were having the under root, right? We were having basically first of all the pooled proportion, that is PC, the real one. So that was coming as 0.08, right? And that was multiplied by 1 minus PC. So 1 minus PC we are getting 0.92. So these both are actually multiplied first of all with each other. After that we were having 1 upon NA plus 1 upon NB, right? So in that case 1 upon 200 here plus 1 upon 200, right? Because NA and NB are having the same values in this particular case, right? So after solving this out, so P dash A minus P dash B. So basically you could just say that it follows, it basically follows the, follows an approximate, normal distribution, follows an approximate normal distribution. Okay, this basically follows out an approximate normal distribution. Right, now how to calculate out the p value, that you actually know. I'm just not going to repeat that out again here because we have already done many of the questions regarding that particular thing. So p value you are going to get out from using this normal distribution, that is 0.1404. Okay, just match it from your whatever the answers you are actually getting out. Fine. Okay, now here after this basically now basically we are left with the finding out the proportions and the graphs, right? So that will be not doing right here. I would be okay now finding out the estimated proportions, finding out the graph, and giving out a conclusion. That is one of the things which we have already discussed one time, as we have done out the similar question to this, right? So what I would just do here is that I would give you time to solve out this onto your own. Okay, just I would be pausing up here. You solve out this particular question, rest of the things onto your own, and come back in the next video and I'll be displaying you the further answer for this particular question. Right, so hope you just got that and solve this thing on your own and just verify it from my next video that whether whatever you had just gone ahead and solved that out, is that absolutely right or not. You could just take the help from the previous video in which we had solved out the question, one similar question like this, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically in this video we are going to discuss regarding the matched or paired samples. That basically what are these matched or paired samples, that how are they used and what to use in this particular topic, and all the things are the things that we are going to discuss in this video. Right, so let me just put on the topic first of all and let me take out the color. So here we have the color and that is actually matched or that is matched or paired samples, right? Yeah, this is the topic for the discussion of today. So here I'll be mentioning out some points as well, and I'll be mentioning out some formulas as well into this particular topic. Let me just quickly take out some color for writing out the things ahead, and then we can just absolutely move ahead with this particular thing. So let's get started, and my number for topic 1 number will start straight. So first one is basically my simple random sampling is used. So the very first thing regarding this is that the simple random sampling is used. So whenever we just go and solve out the question regarding the matched or the paired samples, okay, so in that case the simple random sampling is used. Right, this is the very first thing that we actually have out here. Moving towards the second one, we have the sample sizes. So here comes regarding the sample sizes. So the sample sizes are often small. So into this particular one, that is matched or paired samples, the sample sizes which are there that are often small. Okay, then we have that two measurements, or you can just call it as samples. Okay, two samples are drawn from the two samples are drawn from the same pair of so from the same pair of individuals or objects So whenever we talk about the two measurements in this, so the two measurements are drawn from the same pair of individuals or the objects. This measurement is as per the samples only. So I could just put out the statement in this way, that the two samples are drawn from the same pair of individuals or the objects, right? So let me put out a dot here. That's over. Right. Now, what about the next points which we are having? So point number 4 comes here and it says that the differences are calculated from the matched or paired samples. So samples, right? So whatever the differences we are having here, that are calculated either from the matched or from the paired samples, right? This is the use for the matched or paired samples. After that comes the next point, that is point number 5. So here comes that the differences form the sample. Let me come down, get out some space for writing. Yeah. So differences form the sample that is used for the hypothesis test. So the differences that are formed of the differences from the samples that is used for the hypothesis test. Right, so basically just have a look here on the last point which we have mentioned, that differences are calculated from the matched or the paired sample. That is absolutely okay, right? That whatever the differences are there, these are calculated either with the matched or the pair samples. And whenever these differences are calculated, so the differences form out the samples that are basically used for the hypothesis test. Got that? So this is the whole idea regarding that matched or the paired samples, right? This is the idea. After that, we even have some more thing for this to discuss out. Let me just go ahead, get out some space for me. Let's write out the 6th point. This is the last point actually. Okay. So into this point, it says that the the matched pairs, the matched pairs have differences, differences that either come from a population that is normal, or the number of differences is sufficiently large, so the distribution of the sample mean of differences is approximately normal. Right, so the matched pairs have differences that either come from a population that is normal, or the number of differences is sufficiently large so the distribution of the sample means of differences is approximately normal. Right, this were the some of the little, like, some things and some points regarding the matched or the paired samples, right? That the simple random sampling is used. Second one, sample sizes are often small. Two measurements are drawn from the same pair of individuals or the objects. So here the measurements for actually the sample. So I could just actually say that the two samples are drawn from the same pair of individuals or the objects, right? Differences are calculated from the matched or paired samples. The differences from the sample that is used for the hypothesis test. The matched pairs have differences that either come from a population that is normal, or the number of differences is sufficiently large so that the distribution of the sample mean of differences is approximately normal. Right, so hope you just got the idea regarding whatever I just mentioned out the things right here. Fine. Okay, after that, it's not like totally completed. I have some more things to tell you regarding this particular topic only. Yeah, listen to me. Here, basically, whenever we do a hypothesis test for a matched or a paired samples, so basically, subjects are matched in pairs and the differences are calculated, right? These are some things which we had already written out onto the above like points. So the differences, basically, what are the differences? Differences are the data, right? Which I just mentioned, that the differences are basically calculated, the subjects are matched. What is our differences? That differences are data, right? Which will be getting out from there. As soon as the differences are calculated, again we just get out some data, right? Now, basically the population mean for the difference is then basically tested using a student's t-test for a single population mean. After that, after finding out that differences, that is the data actually, what we do, we basically take out the population mean for the difference, and that is basically tested using the student's t-test for a single population mean, which will be having n minus 1 degrees of freedom. Okay, and basically what is the n? N is basically the number of the differences. So the t-score, or the test statistics, basically what we have, that is t is equal to xt bar minus mu d divided by sd upon under root of n, right? So this is the formula which would be actually coming. So what is this mu d? Actually, this mu d is the population mean for the difference only. That mu d will be tested using out the student's t test, right? So this is the idea regarding out this particular matched. Okay, just one second. Let me go ahead above once again. Yeah, this is the idea regarding the matched or the pair samples which we actually have out here. So in this, basically a simple random sampling is actually used out in the matched or paired samples. After that, sample sizes are often small. Right. Then the two measurements are drawn from the same pair of individuals or the objects. Differences are calculated from the matched or the paired samples. The differences from the sample that is basically used out for the hypothesis test. The matched pairs have differences that either come from a population that is normal or the number of differences is sufficiently large so that basically the distribution for the sample mean of differences is approx normal. Right now, what about the t-score? First of all, I just told you some things orally. Let me just repeat that out here as well. So in a hypothesis test for a matched or the paired samples, subjects are matched in pairs and the differences are calculated. Let me put on here that the differences are calculated. Differences are calculated. And what are these differences which we will be getting out? These differences which we'll be getting out is basically our data. The differences are the data actually, right? Now, actually, when we're in the next video, basically we are just going to see one example for this particular thing. There you'll be getting out two columns, and from that two columns, we'll be making out a third column that would actually contain out the differences of the first two columns, right? This is the idea. Okay, after that, basically for calculating out the population mean for the differences, so in that case mu d was a variable which we had put on, and like the symbol or the denotation you could just actually say. So that is basically tested using out the student's t test for a single population mean, which would be having n minus 1 degrees of freedom. What's the degrees of freedom? We had really learned this thing in a too much detail into the previous video. So I'm just not going to repeat out these things again and again in the further videos. So if you have some doubt, you can just go back and again have a look over that particular video. Right? Yeah. So n minus 1 was basically the degrees of freedom, and what was n into that? So n is basically the number of the differences here, right? So this is actually all set, and after that we saw out one formula regarding that test statistics or the t-score. So let me just first of all put on some highlighter into my hand so that I could just highlight the things as well. So yeah, t is basically equal to x bar d minus mu d upon SD into the bracket SD upon under root of n, right? This was the formula which we had seen. Now into the next video, when we solving out the question, we'll be putting out the values. So in that case, in that place only, I'll be telling you that how to put out the values onto these particular things which we are actually given out here, right? So hope you got out this topic very much clearly regarding the matched or the paired samples, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So as we have discussed in the previous video regarding the matched or the paired samples, today we are going to see one question regarding this particular topic, right? So the question which I had actually taken out here, it says that a study was conducted to investigate the effectiveness of that is hypnotism in reducing pain. Okay, results for randomly selected subjects are shown in the table. This table which you are actually able to see out here, this is the table which it is actually talking about. After that are shown in the table. After that, the before value is matched to an after value and the differences are calculated. The differences have out a normal distribution. So the problem is that basically are the sensory measurements on average lower after hypnotism or basically test at a 5% significance level. Fine. So this is the question which we need to solve out here. Basically, first of all, I just hope that testing out at a 5% significance level, you must be able to do now this thing onto your own, because really we had done a lot of things regarding testing out a a significance level, right? We had seen some things regarding the 1% significance, and even once we had just done out this 5% significance as well, right? Okay, so let's get started and solve out this particular question. So what I would just do here is that I would be writing out the particular things. Okay, just 1 second. Okay, right here. So fine. And okay, what I am giving this table. Fine. So first of all, what I'll be doing is that I would be calculating out the difference. So how we calculate the difference? I already mentioned that it is a data. So difference is basically calculated regarding the first of all after minus before. So after minus before. From this particular thing, we calculate out the difference. So I would just write difference is equal to after minus before. Okay, let me take out a color from here so that we can start writing the other things. And let me now make out a box as well. First of all, let me move down. Yeah, because this much space you would be needing for making out the table, because yeah, table is a little bit large, right? So like this, the table could actually be made out. Yes, this is absolutely okay. After that, we could just divide this thing into the 3 parts, because first one would actually be having the upper, before, after, and the difference as well, right? Now let me just again took out some another line from here, and okay, just 1 second. Draw, and here comes the line, and okay, why it is not getting selected right here? Fine. So let's come down again. Okay, just give me 1 second. This I would just remove this out, and again take out a line from here, and find just 1 second. Come down now. So this line would be made up till this particular place. Okay, now let's get started with the things. So first of all, we'll be writing all the after values, then we'll be writing out the before, and then at last we'll be writing out the difference. So this one is for the after, this one is for the before, and this one is basically for the difference. Okay, so let's see that what the after values. See, after is this down one, not the above one. Okay, 6.8, 2.4, 7.4. So 6.8, 2.4, 7.4, and 7.4. Then we have 8.5, 8.1, 6.1. Then we have 8.5. We have 8.1. Then we have then we had 6.1. And above we are having 3.4 and 2.0. So here goes the 3.4 and 2.0. Great. What about the before thing? So 6.6, 6.5, 9.0, 10.3. Okay, so here we are having 6.6, 6.5, 9. Then we have 10.3. Okay, after that what we are having 11.3, 8.1, 6.3, 10.6. Okay, we are having 11.3. Then we are having 8.1. We had 6.3 and we had 11.6. Now the difference which we had talked about into the previous video as well, that difference would actually be calculated after the subtraction of both of these things. Okay, as soon as you subtract after from before, the difference would be out here. So here it is 0.2, then we have minus 4.1. Okay, let me write out minus clearly. Actually it's minus 4.1. Then we are having minus 1.6, minus 1.8. Let me come down. Yes. Then we are having minus 3.2, minus 2, minus 2.9, and at last we are having minus 9.6. Okay, so these are the differences which actually I am having here. Right, so my table is now actually made out. After this, what we do? We basically take out the data for the differences. Separately, we just take that out. So I would just write here that the data for the test are the differences. Okay, so the data that we'll be taking out for the test will be the differences that we had calculated out. So that was 0.2 minus 4.1 4.1, 1.6, 1.8, 3.22. Okay, then after that it was basically minus 1.6, minus 1.8, minus 3.2, minus 2, and we are left with two more things, minus 2.9 and 9.6. Okay, that is minus 2.9 comma minus 9.6. Yes. So these are the, like, now this is the data for the test, and these are the differences that will be like finding out the data, and this is the data on which we'll be performing out the test. Okay, find out the sample mean. So the sample mean, yes, what is the sample mean for the difference? The sample mean of the difference. What is the sample mean of the difference? So that is actually, it is represented by x bar d, and it would actually, you can calculate, and it would come as 3.13. Okay, and what about the standard deviation? So the standard deviation of the, let me now come down, the standard deviation of the differences that is basically is represented by SD, and that is 2.91. You can just verify out these values onto your own, right? So when yesterday we had discussed about, like in the last video we had discussed about the question, so that was x bar d minus mu d upon st upon under root of n. So yeah, these say all the values I had just found out for today's question, right? So this is the one which we had actually find it out. After this, what about the mu d? Let me just write out something. So let mu d be the population mean for the differences. So let that mu d be the population mean for the differences. Now what we'll be doing, we'll be using the subscript, that is d, for denoting out the differences. So let me write out that we use the subscript small d, that is small d, to denote the differences, right? So we will be using our subscript d, that is basically for denoting out the differences. After this, we are now having out the random variable, that just put out the hypothesis test and apply out all of the things. So let's do that particular thing. I would write capital X bar d, that is equal to, I just say that random variable, let's say, and this is the, let it denote the, okay, that is not the main, that is the mean. Okay, so the main difference of the sensory measurements measurements. Okay, yes, so this is the idea for the measurement. So here we have h naught is basically mu d, and that is greater than equal to 0. Right, so basically after that, mu d, basically what is that? That is the population mean of the differences. So if there is no improvement, so we can apply one more thing, that h naught is basically mu d is less than 0. Right, this is the also one thing that we can apply out, right? The score should be lower than the hypothesis, right? That we are, like, actually is in the question. So the score should be less than that, and the differences as well should be negative to indicate out the improvement, right? These are the conditions which actually apply out. Now we will be using out the distribution for the test, right? So what I would be doing here is that I would be just coming down and just writing out the thing here, that is the differences. No, sorry, that is not the differences, that is the distribution. Okay, that is the distribution for the test. Okay, the distribution for the test. So you can just find out that distribution for the test. You can just denote that df, and you can just write at n minus 1. So that would be 8 minus 1, and which is equal to 7. So now how did I found out the 8? So just have a look over this table which was given out at this particular place. So results are randomly selected when the before is matched. Okay, so basically here are total 8 points. Okay, 1, 2, 3, 4, 5, 6, 7, 8. right? So from there I just got to know regarding that this basically the value for n is actually 8, right? So after this, basically now we are left with calculating out the p-value, plotting out the graph, and then finding out the sample mean and the standard deviation, comparing out the p-value alpha, and making out a decision and then conclusion. So these are some of the things which we are actually doing in the previous questions as well. So I would just give you some time to solve out these questions, this further things onto your own. Just take the help from the previous videos which you had already watched and made out the things for. So there basically you could just find out the things, and from there with the help of that you could just figure out the rest of the things which are left. Otherwise we'll be covering that into the next video, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So now in today's video we are going to discuss about the sampling technique. Now sampling is one of the techniques for which we had already seen out the definition in the previous videos. But today now right here we are going to discuss about the sampling in a very much detail, and other than that basically we are just going to see out some methods for sampling. There are some different 3 to 4 methods for the sampling. So we are just going to see out all of them as well today, right? So I just put out the topic for today, that is actually the sampling for us, right? Okay, now let's get started. So from here I could just choose out a random color and any other one which we can just go on and proceed with the writing. Fine. So what is the sample? So I would just write that one definition here. So a sample should have the same characteristics. A sample should have the same characteristics. A sample should have the same characteristics as the population. A sample should have the same characteristics as the population it is representing. We already know about the sampling, like what's the sample actually a little bit, right? We already are familiar with this particular terms, right? So there is one note regarding that sample and the sampling thing, that a sample should have the same characteristics as the population it is representing, right? That is the absolutely right thing actually, right? Now we'll be discussing about some basically some other methods for doing out the samples. The very first method that we are going to discuss about is a simple random sample. Let me just put out that particular heading is here. So that we are going to discuss about the simple random sample. This is a particular topic that we are going to see right here, okay? So as I mentioned that there are different methods for doing out the random sampling. So but first one we are just going to choose out a simple random sample, right? So now basically here what happens that whatever the form of sampling we are having, each member of a population basically they have equal chance of being selected for the sample, right? Whatever the basically the member of that population, each member of that particular population is having the correct chance for being being chosen out, right? That is the correct thing actually. So in that each and every method has some its pros and some cons. So basically the whatever the easiest method we just use out, okay? So that we just call it as the simple random method. So the easiest method to describe any of the population, any of a sample is called the simple random sample. So I would just write out this particular thing that this is the easiest method actually. Easiest method. Okay, this is the easiest method for describing out the random sample. Okay, now what is this in detail? That will be seeing with the help of example in some other case. Right now we'll be discussing about some other of the random sample methods which we are actually having. Okay, so other random sample methods which we are actually having are, first one is the stratified sample, second one is the cluster sample, and third one is the systematic sample, right? So these are three things that we'll be discussing throughout this video. So let me just go ahead with the very first topic, that here we are having the first one, which is the stratified. I will just write as stratified, and here goes the sample. The second sampling technique actually you could just call it as, right? Fine. So in this basically what happens? So if we just want to choose out to, okay, I will just write that particular thing. So to choose this stratified sample, let me just come down at this place. Okay, so to choose out the stratified sample, divide the population into groups. Okay, now what we just call this as groups as, we just call these groups as strata. I would just not write that thing here, but listen to me very much carefully. That whenever we just like choose out the stratified sample, whenever we just want to choose out the stratified sample, so in that case you just divide out the population into groups, and that groups are actually called as the strata. Fine. And then what we do, and then take a proportionate number, that is proportionate, T-I-O-N-A-T-E, okay, and then take a proportionate number from each stratum, number from each, I would just write that each here from each strata, as priority. Fine, this is how we just do out the stratified sampling. So to choose out the stratified sample, how we just do out that. So we first of all divide the population into different groups and then take the proportionate number from each of the groups which we have divided out, right? This is how we just perform out this particular stratified sample. Right, hope you're very much okay with this particular thing, that how we just do that right here. Second, we are having here as a cluster one. So okay, that's not the second, that's the third one. So I would just write here cluster sample, right? So how we just do that? So I would just write that to choose the cluster sample. So to choose the cluster sample, divide the population, divide the population, we divide out the population into clusters, okay, into clusters. Now clusters is basically the groups as well, the same thing, that is the groups, okay. So to choose out the cluster sample, divide the population into cluster and then randomly select some of the clusters, right? This is how we just do out that cluster sample. So first of all, if you just want to go ahead with the cluster samples, in that case divide out the population into clusters and then randomly select some of the clusters, right? So this is okay. And after that we are having the third one, that is actually the systematic one. So put on the, that's fourth. I would just write that thing as well here. So that is systematic sample, right? Systematic sample. So how we just to do this? So I would just write that to choose systematic sample, to choose out a systematic sample, randomly select a starting point, randomly select out a starting point and take every nth piece of data, and take every nth piece of data from a listing, and take every nth piece of data from a listing. Okay, this one. Okay, just let me come down here and let me remove out this listing because it's not the correct thing, and let me write it once again here. From our listing, and take out the every nth piece of data from a listing of the population. So this is how we just do out the systematic sample. Let me just take out the cursor onto the hand, then I would show you. Right, yes, a systematic sample. So to choose out a systematic sample, randomly select out a starting point and then take every nth piece of data from our listing of the population. Right, this is how we just do out that systematic sample. So these were the four ways for doing out the sampling. So first one was a simple random sample. Second one was basically my stratified sample. Third one was basically my cluster sample, and fourth one was my systematic sample. So these are only the four ways which we actually have here for doing out the sampling techniques, right? So to basically choose out some random sample. So hope you just got this particular idea that first of all, what are the four ways that you can just choose out the sample for, and other than that, basically how to like what are the meaning and basically how to do out particular sample with the help of particular sampling technique, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we'll be discussing about some important key terms in the statistics, right? So we'll be discussing about some important key terms, and I'll just letting you know about all of those things in a little of detail with the examples as well. Right, now this is a video in which you need to listen a lot and write a little bit, right? So just listen to my words very much carefully, whatever I'm just telling you right here. Okay, so let's get started here. Let me just choose out a color to write out the things, and yes, okay, this one is absolutely fine, and right here. Fine. The first term that I just want to discuss about is population. That what is actually a population? Just one second. Let me take out a thinner pen as well, and yeah, okay. So let's discuss about that. What is actually a population? Now, you can consider and think of a population as the entire collection of a person or a thing or any object. Okay, let's say I'm having a collection of different pens. Okay, let's say I'm having a collection of different pens. What is that pen? Pen is a thing. It is an object, right? So when I'm having a collection of different pens with me, so what can we just call that in the terms of the statistics? We can call that particular thing as a population, right? Now, after this population, you have must known that what we have meant from population. So we can simply give it a definition that population is like actually we can define it as an entire collection of persons, things or objects, right? Now, when we just want to study about a larger population, for a single larger population, let's say you are having a population, you are having a population of let's say 50,000. So you cannot study that whole 50,000 population at one go, right? That would be like even a silly task, and that would not at all be possible to study out this much of huge data in one single go. So what we do, we basically select out a different sample from that population, and this is what we call as a sample. So the idea of sampling actually came when we want to select out a portion from a larger population and study that portion to gain out some information about the population. That is actually what we call as sample, or you can call that technique actually as sampling. So I would just write here the second topic for the discussion, that is sample slash sampling. So as I told that, let's say you are having a huge population, we are having a large population to study out a larger population. Okay, then what we do, we select out a sample. Now, what is that sample? So basically the idea of sampling is to select out a small portion. Okay, select out a small portion, or you can just call that as a subset as well. To select out a small portion or a subset, which is basically from the larger population. Okay, to study out that particular portion which you had selected out, so as to gain some information about the population, right? That is what we just call as sampling. Okay, and what is our data? And data are the result of the sampling and the population. So sampling and population, these both constitute and make out our data, and that is basically data are the result of the sampling from a population, right? Hope you just are very much clear first of all with these three terms which I told you: population, sample slash sampling, and the data. Let me revise that once again. What is a population? So in general words, we can say that population is a like it is an entire collection of persons, things or objects. To study larger population, we select out the sample. So sampling is a technique in which we select out the small portions from a large population so as to study about that particular population and gain some information. And what is a data? So data are the results of sampling from a population. Whatever sampling we just do from a population, and whatever result we just get, that is actually called as a data. Right, hope you just are very much clear with these three terms that I had just told you right here. After that, okay, after that we have some other terms as well, so I would just let you know that thing. So the third term basically which we are going to discuss about is a statistic. Okay, so statistic. Okay, now what is a statistic? So is a statistic, it is not that statistics which I had told you in the starting. There's a quite difference between that statistics and this statistic. Okay, so make sure to make out a difference between both of them. So what is a statistic? A statistics is a number that is the property of a sample. Okay, number that is a property of the sample. So let's say you have taken out any number from the sample, and that is a property of that particular sample. So that number will be a statistic that you had taken out from that. Okay, now let's take out an example for this. Let's take out an example. Let's say I consider a one math class. Okay, one math class is basically a sample of the population in all of the math class. Let's say I'm having n number of math classes in a school. So from that all of the math classes, I just took out a simple one math class. So what will that be? So all the n number of math classes which I'm having, that is a population for me, right? And from that I had picked on one particular math class. So that is a sample. Right now I just told you the definition for the population and the sample. Right? That is absolutely clear. Then what we can just see, then the average number of points earned by the students in that one math class at the end of the term is an example of a statistic. Now, in that one single math class, what we can find out? We can find out the average number of marks. Okay, average number of points or marks, whatever we just want to say. So the average number of marks which is earned by a student in that one math class. Okay, at the end of a term, because what are the maths marks will be coming, we'll be calculating that at the end of the term, and what are the average number of marks a student has at the end of a term. That is an example of a statistics. As I mentioned the definition for a statistic, that it is a number that is a property of the sample. So when I just took out this example, in that I had taken n number of math classes. From that n number of math classes, I had simply taken out one math class. In that math class, what I took out, then I just basically find out the average number of marks a student has earned in one single math class at the end of term. This is the data which I had taken out from that particular sample, right? One sample I had taken and the data I have taken out from that particular sample. So what is that? That is called as a statistic. Hope you just got this parameter as well, which is a statistics. Here you need to listen me out very much carefully, because I'm just not writing out any of the definitions, and even I'm just not writing out any of the examples, because that is not at all required here, right? So listen to me out very much carefully and very patiently. Okay, so after the statistic, we have another thing and another word and a term which is actually parameter. Okay, now what is a parameter? So a parameter is a number that is a property of the population. Okay, right now till now we had understood about the number that is a property of the sample. Okay, statistics is the number of a property of a sample, and a parameter is a number that is a property of a population. When we talk about property of a sample, that is statistics, and when we talk about property of a population, so that is actually a parameter. So let me just put on that particular thing here, parameter. Okay, hope you got about the statistics and parameter. These two are almost similar things, only a slight difference. So statistics is property of the sample. When we are dealing about the property of the sample, in that way we can just call the statistics as a key term, statistic actually. And when you are dealing with the property of a population, so in that it is a parameter. Right, this is the idea. Now after that we have one more important term, that is a variable. Okay, so here in the statistics we normally denote out the variables with the x and y. I will just put on the next topic, which is a variable. So that is actually denoted by capital letters like x and y and all those things. Okay, that is absolutely okay. Now what is that? So variable, it is basically a characteristic of interest of each person or thing in a population. Let's say you are having a population, right? In that, what is the characteristic of interest of each person? Okay, that is actually what is called as a variable. Now, variables are also of two types, numericals and the categoricals. So, numericals variables are the ones which take on values with equal units. Let's say give an example. Let's say weight in pounds, time in hours. So, whatever the numerical things you are having, that all come under the numerical variables, and whatever the like characters or strings and persons or thing names you are having, that all comes inside the categorical. So let me just put out the slash here, and here it goes. The first one is basically the numerical for me, and second one basically is the categorical. So numerical deals with all the numerical values, okay, all the numerical values, as I given you the example, weight in pounds, weight in pounds, time in hours, all those things comes under the numerical. And whatever the categorical variables place the person or thing into a category. So whenever we just talk about anything, any person, so in that all comes under the categorical, because it deals with the characters. Okay, so hope you just got out the idea regarding the this numerical and the categorical. And after learning about the numerical and categorical, what we can say about the data? So data are the actual values of a variable. They can be words, and they can be numbers, or they can be words. Okay, so data are the actual values of the variables. Whatever the variables you had put on, whatever the values you are having, either it is numerical or categorical, that does not matters. Right, so that is actually what we call as a data. Fine. So values for the variables, that is numerical variable or a categorical variable, is called as a data. And basically we have one term that is actually datum, D-A-T-U-M. So datum is basically for a single value we just give out the term that is actually the datum. Right, so hope you just got out all of the 5 topics which we have discussed: population, sample and sampling, statistic, parameter and variable. This data we had seen datum, and even at last we had seen data. Now, what's the use of these terms? So I'm just telling you the definitions, because throughout the further videos, I'll be taking out these particular terms throughout different videos. So you are basically able to understand what I am what I'm referring from the population, what I'm referring from a parameter, what I'm taking as numerical, what I'm taking as categorical. So as to clarify and identify all of those things, I told you that the proper and the important definitions which are actually needed to proceed on with this particular course. Right, hope you had just put down all the things, noted out all the things, and if you haven't, so once again go back, rewatch the video and put out the things. So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we are going to discuss about the different levels of measurement. First of all, I would let you know that what we meant from levels of measurement, and after that basically I'll be telling you different types of levels of measurement, right? So let me just come down here for a while, and let me just put on the particular topic which we actually have. I would just click on here, and just let me took out a particular color so that we can start writing out. Fine. So I would just write out here as the topic, which is levels of, and it is measurement. Okay, that we are actually gonna discuss out today. So hope you all have even put out your notes and the things wherever you are writing out the making out the notes. Hope you have just done out all of the things taken out, and let's begin now with the writing stuff. Okay, so first of all, let's see that what does we mean from levels of measurement. Actually, the very first thing that we need to actually understand out here. So the way a set of data is measured is called levels of measurement. So it's called levels of measurement. Okay, so the way a set of data is measured is called a levels of measurement. So basically whatever the way is basically in which a set of data is actually measured, so that is actually called as a levels of measurement. Right, now basically here we have 4 levels of measurement. Okay, so I will just write here 4 levels of measurement. So here we have total 4 levels of measurement, and I would just describe all of them. First of all, list all of them, then we'll be describing all of them in the very detail, right? So the very first one is basically we are having as nominal. Okay, so that is nominal nominal scale level. Okay, the very first one, nominal scale level. Second name is basically the ordinal scale level. So I would just simply write here ordinal and scale level remains the same. Okay. Next we are having interval scale level. So I would just write interval and scale level actually remains the same. Again, we are having that only. And what about the fourth one? Fourth actually we are having here as ratio, and that is a scale level. Okay. So these are the different four types of level of measurements which we are actually having here. So first one is a nominal, then we have ordinal, third one is interval, and the fourth one is basically the ratio. Okay, now what I would just do, I would be describing all of them, each and everything in a very detail. Let's start off with the very first one, and that is actually the nominal one. And here we go with the nominal. Fine. First of all, I would just write data which is measured using a nominal scale, which is measured using a nominal scale is qualitative. Okay, basically we have two types of data, that is qualitative and quantitative. So let's not go too much into those things right now. For now, understand that basically we have two types of data, qualitative and quantitative. Okay, so data which is measured using a nominal scale is basically the qualitative data. Okay, and next thing which is basically about the nominal data, so I would just write that nominal scale data are not ordered. Okay, so basically this nominal scale data is not at all ordered. So ordered data means that data is too much sorted and all those things, but that do not come here in the nominal one. So this was about the nominal scale data, right? Move towards the second part, and that is basically my ordinal level data. So it's almost similar. This ordinal one is almost similar to the nominal only. There is a quite like a small difference between both of them. Okay, I would just write out that thing, data that is measured, that is measured. Let me come down right here. So the data that is measured using an ordinal scale, is similar to nominal scale. Okay, so data that is measured using the ordinal scale is similar to the nominal scale, but in that data there is a big difference. But what's the difference? But I would just write that. But the difference is that the ordinal scale data can be ordered. But the difference is the ordinal scale data can be ordered. O-R-D-E-R-E-D. Okay, so in the nominal one, what was the case? In nominal, the case was that this data is not at all ordered, and in ordinal, the case is that data can be ordered actually, right? Ordered in the case that we can actually sort it in that way, right? So first of all, this was about the nominal and ordinal. This was a quite difference which comes between both of them. Fine. Now let's move towards the third type of scale level, and that is basically the interval scale. So here we go with the interval scale. Okay. Now let's see that what this is interval scale. So the data which you measure, okay, I would just write that thing as well. Data measured. Yes. So data measured using interval scale. Data measured using interval scale is basically similar to the ordinal data only, to the ordinal level only. It's similar to ordinal It is similar to ordinal level. But what's the difference? But what is actually the difference? But the differences between the data. The difference is the data. Okay, the differences in the data. So difference between the interval scale data can be measured through the data that does not have a starting point. Okay, so what are the differences in the interval scale data? That can actually be measured through the data that does not have a starting point. Okay, so this is about the interval scale data. Now moving towards the last topic for this data thing, and that is actually the fourth type of data which we actually have, and which is ratio scale. Now this ratio scale is totally different from all of the other things which we are actually having out here, right? So ratio scale. Okay. Now when we deal out with the data, I will just write that data that is measured, measured using the ratio scale takes care of the ratio problem, and gives you the and actually it gives you the most information. So I will just write that most information, right? So this is about the ratio scale, the data that is measured using the ratio scale that takes care of the ratio problem and gives you the more information. Okay, just N at the last. So basically the ratio scale data, it is like the interval scale data only, but in addition it has a 0 point and ratios can be calculated. Okay, but in the interval one, what we were having? So in the interval we are having that the interval is similar to ordinal level, but the differences of the data. So in that, the differences between the interval scale can be measured through the data that does not have a starting point. Okay, I will just put out a dot and measured which do not has a starting point, okay, let me just come down here. And I will just write a very small thing here because I just do not have space here. That is starting data. So basically it is the difference is that in this, basically in the interval scale data, the differences between the interval scale data that can be measured through the data that does not have a starting point. Okay, but in the ratio scale, that data can be, only difference is that it is totally similar to the interval scale, but in addition it has a 0 point and ratios can be calculated. Okay, 0 point means that the starting point. So these are the 4 types of data which we actually are having here, and these are the 4 levels of measurement: nominal, ordinal, interval and ratio. Right, so hope you just got all of the 4 in the detail, that what are all of these 4s actually, right? So this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today in this particular video, we are going to discuss about the variation. We will be seeing that what variation is, how we do out the variation, and we'll be seeing about the variations in the data. Right, we'll be totally understanding about that variation word in this particular data. Right, so let me just put out a color here and let's go ahead with writing out the definition and the spelling for the name. Okay, so the one which I'm just going to discuss about right here is variation. Okay, and under that the subtopic that comes is variation in data. So that comes here is a variation in data. Right here we are just going to discuss out those things. So variation is basically present in any set of data. Yeah, that can be present in any data set which we are using, or any set of data it can be present. Let's say I just take out an example here. That let's say I'm just taking 16-ounce cans for beverage. Okay, so I'm just taking here as 16 ounce of cans for the beverage. So they may contain more or less than 16 ounce of liquid. That is absolutely true thing, right? So in basically one study, 8 16-ounce can the ounce cans which we have taken out here. So 16 that cans were measured and the product of the following amount of beverages. I just write out that particular thing. Let me just write that. Oh, just 1 second. Fine. I had taken out the example for that, right? I had just taken out the example for 16 cans. Let's take out 16 cans only. Do not let's take out the unit for that. Simply we just take out 16 cans here. Right now, in from the 16 cans of beverage, basically that can contain more or that can even contain less. Right. So once what happened, once eight cans were actually taken and that were actually measured and the amount of beverage was measured in that particular 8 cans. So let's write out some readings. Let's say that was 5.8, we were having 16.1, we were having 15.2, 14.8. 15.8, it was somewhat, let's say 15.9, 16.0, and then we were having 15.5 as well. So these were some of the weight of that 8 cans that came, right? That came here, actually that came upon, right? So what we had taken the ones which were having 16 ounce of liquid into it, right? So it can maybe, it can be more and even it can be less as well, right? That thing here, this study actually shows out. So 18 were actually taken and from that 18, this study shows us that it can be greater and it can be less than as well. So measurement of basically the amount of the beverage which was in a 16 cans can may vary. That can actually vary out, right? Why they can actually the measurement which was taken into the cans, why that can vary? So because different people make the different measurements. Right, as the person differs, the way of measurement of that person as well differs, right? Or basically the exact amount, that was the 16 ounce of liquid, was not put into the cans. These were the two things that can happen. Okay, let me just revise out the example once again because I'm just not writing each and everything here. So, what happened? That once 16 cans of liquid was actually taken, right? 16 ounce of cans were taken and liquid was poured into that. 16 ounce of liquid, right? So basically one study was conducted. So in that 8 16 ounce cans were measured. Okay, 8 16 ounce cans were measured and basically these were the amounts that were produced from that different cans. Now these measurements which we are having, it can be less and it can be greater, and right there we are able to see that particular thing as well because they are all the measurements are actually varying one from each other, right? First one is 15.8, the second one is 16.1, second one is 16.1, the third one is 15.2. Yeah, they're varying a lot, right? What can be the reason? There can be two reasons. First one, different people can have the different way of measurement and different people can make out the different measurement as well. And second could be that the exact amount of 16 ounce of liquid was never put into that particular can. That is why we are just getting this much amount of liquid which is actually measured out. These were the two, these can be the two consequences of this particular data to happen out. Right, so basically manufacturer, basically what they do, they run out the test to determine that if the amount of beverage, okay, amount of beverage in a 16 ounce can fall within the desired range or not. Right, so this is somewhat that actually happens in the data as well. I just taken out some random example. This is the same thing which happens with data, that when you take out your data, so your data may vary somewhat from some data from someone else data which that person is taking. Let's say you are there and one of your friends are there. You both are having the data, right? So one data can actually vary from the other data as well, right? So basically there can be some purpose for that, or either that can be done, and this is a completely natural thing that can actually happen. It's not always the case that data are always same or data are always equal. No, it's not the case. They can vary from person to person, right? So if if two or more of you are actually taking on the same data and getting different results, so basically it's just time for you and the others to evaluate your data taking methods and your accuracy. Okay, let's say you are having the same data, you are given one data and the same data was given to your friend as well. Now, after finding out the results and after conclusion, so basically you must both of you have different results. As I mentioned, that data can vary from one person to the other person. So in that case, if the data is varying, then your result may vary. But for that, basically what can you actually apply for checking out that what are the measurements you have made out, what the result you have concluded, is that correct or not? So in that case, basically, what you can just do, you can re-evaluate your data taking methods, and you can re-evaluate your accuracy as well, which you had put on onto that particular data. So this is what we call as variation in data. Data may vary from same data is given, but that data may vary from one person to other person. But it's not the case that you have done out the wrong results, you have concluded out the wrong results, or the another person has concluded out the wrong results. It's not that case. It totally depends upon your accuracy, that what you are applying into that particular thing, and the data taking methods that you are actually applying. Right now, I've just taken 4 random sample methods before. Let's say you had taken any random sample method and a friend has taken any random sample method. So that are different, right? So in that case, these are some variations in the data that may actually happen. So not to just too much worry regarding that thing. Only the thing is that just re-evaluate your data taking methods and re-evaluate your accuracy which you had put on onto that particular thing. Right, hope you just understand out that what is the variation in data and how these variations actually occur out. Right, so this is all for this video. Till then, thank you and take care. Hello everyone, my name is Shambhavi. Hope you all are doing well. So today we are going to solve out the question in the statistics basically. So we are going to solve out the question for this independent groups, right? So we'll be seeing and going throughout this question. What are the formulas I will be using? We have already discussed all of those things into the previous video, right? So I would just not repeat that once again here. I would directly put on the formulas onto the particular questions and get out the answers for that. Right, so let's get started here. Before that, just let me quickly choose out a color so that we can proceed on with the stuff and doing of all the stuffs, okay? Right here. So this is my question, that is, the average amount of time boys and girls ages 7 through 11 spend playing sports each day is believed to be the same. An experiment is done, data is collected, resulting in the table below. Both populations have a normal distribution. So this is basically the whole idea. We are having here the sample size for the girls. For the boys, we are having the average number of hours playing sports per day, and the sample standard deviation for both of them. All of these things we are actually having out here, right? Now, okay, what's my question that I need to find out the answer for? So my question that I need to find the answer for is there a difference in the mean amount of time boys and girls ages 7 through 11 play sports each day, just at the 5% level of significance, right? So we are, first of all, we need to find out the difference, that is there any, and after that we need to test it at the 5% level of significance, right? So let's get started and solve out this particular question. So I would just write here solution. Let's write out here and start up. Fine. We are already knowing the population standard deviation. So I would just write that the population, I would just put on that particular thing because that is the thing which we already know. So I would just write the population is standard, and I would just put on here as deviation. The population standard deviation is, okay, so population standard deviation is not known to us. Only sample standard deviation is known. The population standard deviation is not known. Okay, the sample standard deviation we know, but the population standard deviation we do not know. And yeah, these both are the different things, right? We are already understood and discussed about a lot of all these things in the previous video. Fine. Okay, now let's take a page variable. Let's take a variable that is g. Okay, so I will just write that let g be the subscript for girls, and b the subscript for boys. Okay, I'm just taking 2 different variables for the girls and even for the boys, and we with a subscript for, and I would just write here for boys. Okay, I'm just taking both of the respective things, right? That I had just put on here. After that, I would just put on then. Okay, then I will put out a comma and I would just write here then mu g. Okay, then mu g is the population mean. It is the population mean for girls, and mu b, I would just write here mu b is the population mean for the boys. Is the population mean for, let me come down for, and I will just put on here as boys. Okay, right. So these are the things which we are listed above. So population standard deviation is not known. So in that case, let G be the subscript for the girls and B be the subscript for the boys. Then mu G is the population mean for girls and mu B is the population mean for boys. Okay. After this, I would just put on here that this is a set of two independent. This is a set of two independent. I would just write independent. Okay, this is a set of two independent groups. Okay, the set of two independent groups, and comma, we have even two population means. So I'll just write two population and put on here as means. Okay, right, that all the things are actually done out here. What I would just come down, I would just come out and go the things for the random variable. I just put out here as random, and here we have variable. Fine. So what we are gonna do here is that we will be writing out that what's the difference between the sample mean in the amount of girls and the amount of boys. I would just do that. So I would simply write x bar g minus x bar of b. Okay, this is basically what this is the difference in the sample mean amount of time girls and boys play sports each day. Play sports each day. Okay, so this is the idea random variable xg like x bar g minus x bar b. That is the difference in the sample mean amount of time girls and boys play sports each day. Okay, that is absolutely fine. Now what I would just do here is that I would be coming down once again and right. Now let's give it some denotions and let's put out some values here. Okay, so in that case I'll be writing here h naught. Okay, h naught is basically what is that? That is mu g, and that will be equal to mu b. That is my mean for the girls and mean for the boys. And what I would just do, I would just write mean for girls minus mean for boys, that is equal to 0. Fine. Right here, now what I would just even do, I would just put one more condition. Let's say that is HA, and that would be mu of G is not equal to mu of B. First was my condition that they both are equal, and second is my that they both are not equal. So mu G minus mu B will not be equal to 0. Find my two conditions that I have applied out. Okay. Now, let me just write out here. Fine. So I would just now put on the things. Right. So the words that are written, which is the same. The words that are written, that is the same, tell you H naught has an this equal to sign. Okay, the words the same, tell you H naught has an equal, right? So since there are no other words, since there are no other words to I would just put on here indicate, since there are no other words to indicate HA. Okay, that is my HA. Then in that case, then assume that it is different. Fine. Okay. See, the words the same tell you H naught has an equal to sign, right? Then there are no other words to indicate HA. Then assume that basically it is different, right? So here what we are doing here, we are taking a two-tailed test. Okay, I would just write that here. It is a two-tailed test which we are actually trying to do out here, right? Now, let's do out the distribution for this particular thing. So let me just come down here, and I would just write distribution for the test. I would just write here distribution for the test. Put out a full stop, and I would just write here use T of DF. Let me remove this out. Use, and I would just write here use T of, and I will just put on here as DF. Okay, use T of DF where I would just put on where DF is calculated, where DF is calculated using the, where DF is calculated using the DF formula which we already have for the degrees of freedom. Yes, right, remember we have already seen that yesterday. Formula for independent groups. Okay, for independent groups. Okay, now you are already known with the formula, that what's the formula for calculating out this degrees of freedom. So I would just not let you know whole procedure, whole things in hand. Okay, you already know the formula, you already know that what are the symbols that belong to what. So basically put out that formula. Fine. So I would just simply write the final answer for DF. So that is approximately equal to 18.8. Just find that on your own. Okay, I'm just not gonna put out the things again and again totally for you. Okay. Okay. So, and even what you could do, you can just find out the p-value as well. P-value, and how will that be found? So p-value can be found. P-value can be found using students t distribution, using students t distribution. And if you're just not getting that how to put out the formula and all those things, so you can just ask all the things to me in the chat box, right? So p-value can be found using students t distribution, and that would be approximately equal to, that you also need to find out on your own. So the value for that would be approximately equal to 0.005 or something like that. Okay, fine, just put out that find out all of those things. Now what we can just do out here is that we can actually make out a graph for this particular thing. Let's see how to make out the graph. Let me put out this, and let me just put out this particular thing like this right here, and fine. After this I would just put out and make out the graph for this thing. Okay, 1 second. So it is a little bit of graph like this, and here we go. Fine, absolutely okay. And here I'll just put out the things like this. After this I have here two portions which are actually colored out, and I would just write the things onto that. Now what are these actually? These are my p-values, the half of this p-value and half. So I would just write out here half of p-value. So what was my p-value which was founded above? So that was around 0.055, it was around 4. Okay, it was around this time. So when I just 1/2 here, so it would be around for me 0.00, and it would be 28. Again here as well, this is the half of my p-value, so that would again be 0.028, same value. Okay, let me now just come down here and plot the other things for this particular. Okay, just 1 second. Yes, now here what do I have? I have the values in middle, it is 0, here it is minus 1.2, and here it's basically plus 1.2. After this, what else we have here to put on? Okay, we have here x of g bar minus x of b bar like this. Okay, we have this as well. Okay, fine. So these are the things which we are actually having right here. So and this portion is actually shaded, so I would just put out the some things like this, right? Fine, this is the graph which would actually come. Now what are the things that we can just conclude from here? So we were already given SG, right? We were already given this particular thing, and let me just go above and show you where we are getting. So right, so we are already given this value which is under root of 0.75, right? Under root of 0.75. So I would just write SG is equal to under root of 0.75. So what is the SB? SB is as well given as when that we had already seen. So we could just write that x bar g minus x bar b. So that is equal to 2 minus 3.2, and that would be actually equal to minus 1.2. So basically what is this minus 1.2? Hope you have just seen out the graph. I just plotted out two things, minus 1.2 and plus 1.2 right here. So basically it is the same thing only. So I would just write here half the p-value is basically below 1.2, below minus 1.2, and basically half is above 1.2. Okay, now since basically we can just now make out a decision here. So I would just write out a make a decision. We can finally make out a decision here that since alpha is greater than p value, that we are already figured out here, right? That alpha is actually greater than p value. What is my alpha? Alpha is my 1.2, which I have actually got out here. So this is greater than p value. So what we'll be doing, we'll be rejecting the H naught. This means, so the statement which I have written above, this means you reject mu G, which is equal to mu B. The means are different. I would just write here that now the means are different. The means are different, right? So hope you just got out this question, that how I have proceeded on with this question. Now this question is even having the second part, which I just need to find out, test at the 5% level of significance. So I would just give you some time to figure out this particular question on your own, and we'll be discussing at the answer of this particular question in the next video, right? So hope you just got the idea that how you would be able to solve out the questions like this. Now this 2 and this 3.2, hope you just remember the idea that here the 2 and 3.2 which I had used out this xt minus xp, it is from that particular table only which I am having here, right? This 2 and this 3.2, right?